Hello there, welcome to Heal with Felix. A small corner made just for those who want to let the mind unwind, to let the thoughts of the day settle slowly like leaves falling onto still water. Tonight, we'll drift together through a question that feels both enormous and strangely intimate. How small are we inside the Milky Way? Just thinking about it might make your chest tighten and expand all at once, as if something is both heavy and weightless. But don't worry, we'll take it slow, because sometimes to truly understand vastness, you have to start with the smallest things, right here where you are. Maybe it's the dim glow from your screen, maybe it's the quiet around you, or the soft sounds of late night. And within all that, a small awareness in your mind, big enough to think about galaxies. Where are you listening from tonight? Perhaps you're curled up under blankets, or there's gentle rain outside your window. Maybe the hum of the city at night is drifting through. Wherever you are, the sky stretches above. Whether you can see it or not, hidden by clouds, by city lights, it's still there. That vast ocean of stars, of planets, of endless dark space. And somewhere in that darkness is our home. Not just Earth, but the broad disk of stars we call the Milky Way. And somewhere inside it, so small that no telescope could ever point you out, is you, breathing, listening, wondering. If this gentle drift through space helps you unwind, helps your thoughts slow down, that's exactly what I hope for. If you can let this video play softly in the background, it helps this small corner of calm find others who are also searching for something peaceful to fall asleep to. So settle in now. Let your breathing even out, and if you can picture the faint shimmer of the galaxy above you, a pale band of light so familiar yet so distant in meaning. It's time to take a slow, careful look at where we stand in all of this. For most of human history, people didn't even know what the Milky Way was. To the naked eye, it looks like a hazy cloud, a soft stripe of light crossing the night sky. Ancient civilizations wove different stories about it. A river of milk spilled by a goddess, a path of souls, a scar left by celestial fire. No one knew they were looking at billions of stars. When you stand outside on a clear night and your eyes adjust to the darkness, that band of light is your edge-on view of our galaxy. We're inside the disk looking through its densest part, like standing inside a glowing fog. It's easy to forget that every faint glimmer there is a sun, and most likely has its own system of planets. Yet from here, it feels small enough to hold in your gaze. We live in a world built to human scale. Roads, trees, rooms, even mountains. They all fit roughly within the range of what our senses can handle. The mind adjusts easily to things you can see and touch. But scale in space is different. It's so large that normal comparisons fail. If you try to imagine the distance between Earth and the Moon as just a few centimeters, then the Sun would be several meters away, and the next star would be tens of thousands of kilometers farther. The Milky Way itself, it would stretch beyond imagination. So when we ask how small we are inside it, we're really asking about proportion, about perspective, about what it means to occupy a single point in a structure beyond measure. Right now, as you listen, you're sitting on a planet orbiting a medium-sized star in a quiet suburb of the galaxy. The Sun isn't special. It's one of roughly 400 billion stars in the Milky Way. And most of those stars are older, larger, or stranger in some way. Around each of them might be planets, rocky worlds, icy bodies, gas giants, some familiar, some impossible to imagine. If you picture it all together, you get a spinning disk of stars roughly 100,000 light years wide. To cross it at the speed of light would take longer than human civilization has existed. And somewhere in that colossal expanse, tucked away in a small spiral arm, is us. A few atoms organized briefly into the shape of people thinking about how small we are. The contrast is dizzying, isn't it? But it's also grounding in a way, because everything enormous starts from something tiny. And to understand how small we are, we need to start with what feels familiar. So let's begin here. Right here, with the ground beneath you, Earth, the planet you're resting on right now. It's about 12,700 kilometers across, wide enough that if you started walking in a straight line, it would take you months to circle back to where you began. That sounds large, and it is by human measure. Every mountain you've seen, every ocean, every forest, all of it fits on this sphere of rock and water. But in the scale of space, Earth is just a beginning point, a small blue marble floating in an ocean of black. About 400,000 kilometers away, roughly 10 times around Earth's equator, is the Moon, our closest companion, the only other world humans have ever stood upon. It takes light just over a second to cross that gap. One heartbeat, and the light has traveled from here to there. When astronauts went to the Moon in the late 1960s, the journey took 3 days. 3 days to cross a distance light covers in a single breath. Now let's move a little farther out. The Sun sits about 150 million kilometers from Earth. We call this distance one astronomical unit, 1 AU. It's a distance so vast that light itself takes 8 minutes to travel it. So when you step outside in the morning and feel sunlight on your face, you're feeling warmth that left the sun before you took your last 10 breaths. The light touching you now began its journey 8 minutes ago. If Earth were the size of a small bead, the sun would be a large beach ball about 10 meters away. And even that comparison doesn't quite capture it, because the space between feels empty in a way that's hard to describe. No air, no sound, just silence and distance. Beyond Earth and the Moon, beyond the Sun's warm glow, lies the rest of our solar system. 8 major planets, each following its own path around the Sun, each one a world unto itself. Mercury, closest to the Sun, scorched and silent. Venus wrapped in thick clouds that trap heat until the surface glows like an oven. Then Earth, our home, with its blue oceans and swirling white clouds. Mars, the red planet, cold and dusty with canyons deep enough to swallow mountains. Farther out, the giants. Jupiter so large that more than 1,000 Earths could fit inside it. Its storms rage for centuries, swirling in bends of cream and rust. Saturn elegant with its rings of ice and rock, stretching hundreds of thousands of kilometers into space. And beyond those in the cold outer reaches, Uranus and Neptune, pale blue spheres of gas and ice spinning slowly in the dim light that barely reaches them. From the Sun to Neptune is about 30 astronomical units, 30 times the distance from Earth to the Sun. If you could somehow travel at the speed of light, it would take over 4 hours to make that journey. 4 hours of crossing empty space, passing planet after planet, each one a small island in an ocean of darkness. But even Neptune isn't the edge. Beyond the planets lies the Kuiper Belt, a region of icy bodies and dwarf planets drifting in the cold. Pluto lives here, along with thousands of other frozen worlds. Some are round like planets, others are jagged and strange. All of them orbit in the twilight, where the sun appears no brighter than a distant star. The Kuiper Belt stretches out to about 50 astronomical units. 50 times farther than Earth is from the Sun. And beyond that, the Oort cloud. The Oort cloud is a vast shell of icy objects surrounding the entire solar system. It may extend as far as 100,000 astronomical units from the Sun. That's nearly 2 light years, 2 full years of travel at the speed of light just to reach its outer edge. This is where comets are born. Occasionally, one is nudged inward by a passing star, or the gentle tug of the galaxy's gravity. It begins a long fall toward the Sun, and when it gets close enough, the ice starts to vaporize. A glowing tail forms, stretching millions of kilometers behind it. That's what we see from Earth. A visitor from the edge of our solar system, briefly lit by the Sun before returning to the cold. The boundary between the solar system and interstellar space isn't a line you can point to. It's more like a gradual fading. The Sun's influence, its solar wind of charged particles, grows weaker and weaker until it finally blends into the space between stars. That boundary is called the heliosphere. The Voyager spacecraft crossed it years ago. They're now farther from Earth than any human-made object has ever been, and yet they are still so close compared to the nearest star, still within the faint outer edges of what we call home. Now these distances, they're hard to hold in your mind, aren't they? Numbers like millions and billions start to blur together. So let's try something different. Let's shrink it all down. Imagine the Earth is a marble, just 1 centimetre across, small enough to hold between your fingers. On that scale, the moon would be a smaller bead, about 3 centimetres away. Close enough to see clearly. Close enough to feel like it's part of the same space. The sun, though, it would be a sphere over 1 metre wide, about the size of a large exercise ball. And it would sit about 100 metres away, the length of a football field. Mars, at its closest, would be another small marble about 70 metres farther. Jupiter would be the size of a large orange, nearly half a kilometre away. And Neptune, a smaller sphere, sitting over 3 kilometres from the Sun. On this scale, the entire solar system from the Sun to Neptune would fit inside a small town. You could walk from one end to the other in an afternoon. But here's where it gets strange. On this same scale, the nearest star to the Sun, Proxima Centauri, would be another metre-wide sphere placed over 2,000 kilometres away. 2,000 kilometres. If the Sun were in London, the nearest star would be somewhere past Moscow, and between them, nothing up. Just empty space. No planets, no asteroids, nothing but a few atoms of hydrogen per cubic metre. A darkness so complete, it's almost perfect. That emptiness is what makes the galaxy so hard to imagine. Even though it contains hundreds of billions of stars, the space between them is so vast that they almost never interact. Light crosses the gaps freely, but matter, solid, tangible matter, is incredibly rare. When you look up at the night sky and see stars scattered across the darkness, what you're really seeing is that emptiness. The stars look close because their light reaches you, but the distances between them are beyond anything in human experience. If you wanted to travel to the nearest star at the speed of the fastest spacecraft we've ever built, it would take more than 70,000 years. 70,000 years to cross the gap between two neighbours in the galaxy. That's longer than all of recorded human history. And yet on the scale of the Milky Way, these stars are practically touching. They're part of the same local neighbourhood, the same small cluster of light in one tiny corner of one spiral arm. This is the scale we're working with. This is the framework that holds everything we know. Distances so large that even light takes years to cross them. Space is so empty that calling them empty doesn't quite capture it. And somewhere in all of this, on a marble-sized planet orbiting an ordinary star in a quiet part of the galaxy, is you, breathing softly, listening, held gently by the gravity of a world that itself is held by the gravity of a star. And that star in turn is held by the gravity of 400 billion others, all turning together in a slow, silent spiral. The size of it all doesn't diminish you. It simply places you like a single note in a symphony, small but necessary, brief but real. And now that we've traced the distances from Earth to the edge of the solar system, from the familiar to the incomprehensible, we can take the next step outward, toward the stars themselves, towards a structure that holds them all. But for now, rest in this, the knowledge that you're sitting on a small world, held by a small star in a system that stretches farther than you could ever travel. It's not lonely. It's belonging to something vast, something patient, something quietly beautiful in its endless motion. When you stand under the night sky and look up at the brightest points of light, it's tempting to think they're all stars. But many of them are not. Some are planets, our familiar neighbours, reflecting sunlight back at us across vast distances. They're the other members of our solar family, orbiting the same star, moving along paths that never cross, bound by the same gravitational thread that holds Earth in place. We've given them names, sent machines to visit them, studied their faces through telescopes, but they remain distant friends, close enough to see, far enough to never touch directly. The nearest of these companions is the moon. It feels close, immediate, something you can point to and imagine reaching with a single leap. Its presence shapes tides, stabilizes Earth's rotation, and lights the night with a familiar glow. Yet the moon is nearly 400,000 kilometers away. It takes light just over a second to travel that gap. When you look at it, you're seeing it as it was 1 second ago. It doesn't sound like much, but the scale of that distance is enormous compared to what we know instinctively. When the first humans traveled there in the late 1960s, they described looking back at Earth as both beautiful and unsettling. The planet hung in space small enough to cover with a thumb, bright and fragile against the black. Beyond the moon lies a space so wide and empty that even our imagination falters. The next planet inward, Venus, comes as close as 40 million kilometers at its nearest approach. The next one, outward, Mars, can be about 55 million kilometers away when our orbits align favorably. When you hear numbers like that, they tend to lose meaning, so it can help to think of light, which travels at nearly 300,000 kilometers per second. Light from Mars, even when it's closest, still takes about 3 minutes to reach Earth. When we send signals to spacecraft there, it's like sending messages to the past. By the time a rover receives a command, Earth has already moved on. This delay turns the planets into echoes rather than conversations. We see them not as they are, but as they were minutes ago, sometimes hours. The farther out we look, the longer the gap becomes. Let's visit each of them briefly, not as facts to memorize, but as worlds you might imagine drifting past in the quiet of space. Mercury closest to the sun, scorched and silent. A small grey world where day and night temperatures swing from blistering heat to deadly cold. No atmosphere to soften the extremes. Just bare rock under an unforgiving sky. Venus wrapped in thick clouds. Beneath its soft glow lies a furnace clouds of sulfuric acid temperatures hot enough to melt lead. It shines so brightly in the sky, sometimes mistaken for a star about to burst into flame. Beautiful from here, deadly up close. Then Earth, blue oceans, swirling white clouds, the only world we know that holds life. From space, it looks peaceful, unified, silent, a small oasis floating alone in a vast desert of light and shadow. Mars, the red planet, cold and dusty, with canyons deep enough to swallow mountains. It once had rivers and lakes, but lost them long ago. Now it's a quiet world waiting. Its thin atmosphere whispers over ancient valleys where water used to flow. Jupiter, so large that more than 1,000 Earths could fit inside it. Its great red spot, a storm larger than our entire planet, has been raging for centuries. Bands of cream and rust swirl across its surface, driven by winds we can barely comprehend. Saturn elegant with its rings. Thin bands of ice and dust spread across hundreds of thousands of kilometers. From a distance, they look solid like grooves on a record. Up close, they're billions of pieces each one, following its own delicate orbit. Uranus and Neptune. Pale blue spheres spinning in the cold outer reaches. The sunlight that reaches them is so dim, so weak, that standing on their surfaces would feel like perpetual twilight. They're worlds of ice and mystery, barely touched by human observation. These planets, they don't shine on their own. Every glimmer from Venus or Mars is borrowed light. The sun illuminates them, and they return a fraction of that light toward us. In a sense, the solar system is a hall of mirrors, each world reflecting the same source from different angles. The brightness of each planet depends on its distance size and how its surface or atmosphere scatters light. That's why Venus looks so brilliant. Its thick clouds reflect most of the sunlight that hits them. Mars, with its dark, rusted soil, absorbs more and shines less. When you see them in the night sky, you're seeing sunlight that has traveled millions of kilometers, bounced off another world, and traveled millions more to reach your eyes. It's an ancient conversation, happening at the speed of light every single night. Now let's step farther, beyond the planets, beyond the sun's warm glow, into the space between stars. The nearest star system to us is Alpha Centauri, about 4.37 light years away. That means the light we see from it tonight left its surface 4 years and 4 months ago. When you look at Alpha Centauri, you're seeing it as it was when the seasons were different, when you were a slightly different person. Proxima Centauri, part of that same system, is the closest individual star to the Sun, a small red dwarf, dim and cool. If it suddenly vanished right now, we wouldn't know for over 4 years. The light telling us it's gone would still be on its way, crossing the empty space between us. Sirius, the brightest star in our night sky, lies about 8.6 light years away. The light you see from Sirius tonight began its journey over 8 years ago. It has crossed the void between stars, travelled through clouds of interstellar dust, and finally entered your eyes, becoming part of your awareness. Epsilon Eridani, another neighbour, is about 10 light years distant. When you look at it, you're seeing light from a decade ago, a being that started its journey before you made certain decisions, before certain events unfolded in your life. This is what it means to look at stars. You're not just seeing distance, you're seeing time. The night sky is a mosaic of different moments, all arriving at your eyes at once. The sun's light takes 8 minutes to reach Earth. That means when you step outside in the morning and feel warmth on your face, you're feeling something that happened 8 minutes ago. The sun could have changed in that time, flared, dimmed, shifted, and you wouldn't know yet. From Mars, that same light takes about 13 minutes. From Jupiter, anywhere from 30 to 50 minutes, depending on where it is in its orbit. From Neptune, over 4 hours. Light that left the sun during breakfast doesn't reach Neptune until afternoon. This delay, this gap between seeing and knowing, is part of what makes the universe feel so surreal. We never see it as it is, only as it was. Even the light from nearby stars brings news from years ago. From distant galaxies, the news is billions of years old. When you look at the night sky tonight, every point of light is also a point in time. Some stars you see died long ago, but their light is still en route. Their final messages still arriving. Others are just beginning to form hidden in clouds of dust so thick that even the best telescopes can't yet see them. The neighbourhood of night is alive with motion and change, even though it looks still. What we think of as fixed and eternal is actually fluid, always shifting, always becoming something else. We're simply moving through it too slowly to notice. So when you think about our nearest neighbours, the planets that share our sun, the stars that dot the darkness around us, remember that distance and time are woven together. Every glimmer is a memory. Every point of light is a message sent long ago, arriving now in this moment as you listen. The planets reflect the sun's light across millions of kilometres. The stars send their own light across light years, and all of it converges here in the quiet space where you rest, connecting you to everything that shines, reminding you that even in the vastness, even across impossible distances, light finds a way to reach us, to touch us, to tell us we're not alone in the dark. And as we move deeper into the galaxy, as we trace the paths of light from farther and farther away, that connection only grows stronger. The universe isn't separate from you. It's constantly arriving, constantly touching you with photons that have travelled unimaginable distances just to reach this moment. Once we move past the orbit of Neptune, the light begins to thin. The warmth that sustains life on Earth fades until it's little more than a memory. Beyond the planets, the sun no longer dominates the sky. It becomes a bright, hard point of light, not much different from the stars that surround it. Out here, the familiar world of orbits and atmospheres gives way to something quieter. Space feels different, emptier, but also strangely open, as if you've crossed an invisible line between the solar system we know and the galaxy that contains it. This region isn't entirely empty. The outer reaches of our system are filled with debris, ice dust, and the remnants of formation. These are the leftovers from when the sun and planets first came together billions of years ago. Most of the material that didn't form into planets was pushed outward by radiation and gravity, collecting into vast, thin regions that stretch for unimaginable distances. The first of these regions is known as the Kuiper Belt. It begins just beyond Neptune and extends outward for billions of kilometers. It's a quiet zone, a place of frozen worlds that rarely see sunlight, orbiting slowly, almost forgotten. Among those distant bodies is Pluto, along with Eris, Haumea, Makemake, and others, the dwarf planets. They are small, cold, and dim, yet each one carries traces of the early solar system's history. Pluto, once considered the 9th planet, was reclassified after astronomers realized it was just one of many similar objects out there. Its discovery in 1930 was an accident of careful observation, a faint moving dot captured on photographic plates. Even then, it was clear how remote it was. Sunlight there is 1,000 times weaker than on Earth. A day lasts just over 6 of our days, and a year stretches on for more than 2 centuries. When you imagine standing on Pluto, the sun would appear no larger than a bright star. The darkness would feel almost physical. The spacecraft New Horizons reached Pluto in 2015 after traveling for nearly a decade through the void. When it arrived, it sent back images that surprised everyone: a world of mountains made of ice, plains of nitrogen, and faint hazes in its thin atmosphere. It wasn't a dead rock, but a place still active in its own slow, frozen way. After passing Pluto, New Horizons kept going. It's still moving outward, exploring the Kuiper Belt, where countless icy objects orbit in silence. Each one tells a story about the earliest days of our solar system, when dust and gas first gathered under gravity's pull. As you travel farther, the sun's warmth fades completely. The solar wind, the stream of charged particles flowing outward from the sun, begins to weaken. Eventually, you reach a boundary where that wind stops pushing against the interstellar medium, the thin gas and radiation that fill the space between stars. This is the edge of the sun's influence, called the heliopause. Beyond it, the galaxy itself takes over. The space past this point isn't part of the solar system anymore. It belongs to the Milky Way. The Voyager spacecraft crossed this boundary years ago. When they did, their instruments detected the change. The solar wind disappeared, replaced by the faint hum of interstellar particles. They are now farther from Earth than any human-made object has ever been, drifting outward, with no destination carrying a record of our existence. What lies beyond that boundary is difficult to describe. The darkness becomes more complete, yet it's not empty. Between the stars lies a thin mist of atoms and dust, the interstellar medium. It's incredibly sparse, with only a few atoms per cubic centimeter, but across the vastness of space, it adds up. This material is the raw substance from which new stars and planets will one day form. In it float the remnants of old stars blown apart in explosions long past. Tiny grains of carbon and ice drift through that darkness, carrying traces of chemistry older than our solar system. If you could drift there yourself, you wouldn't see much. The stars would look sharp at their light, undistorted by atmosphere. The Milky Way would stretch across the sky like a vast pale band. You'd feel no wind, no sound, no sense of up or down. The silence would be absolute. It's a kind of emptiness that defies intuition, not void, but presence spread so thin that it becomes invisible. Out here, the familiar cues of warmth and light no longer apply. The only constant is motion, the slow, steady drift of everything around the galactic center. Distances in this region become hard to measure in the way we're used to. The Kuiper Belt ends around 50 astronomical units from the Sun. That's 50 times the distance between Earth and the Sun. But even that is only the beginning. Beyond it lies a vast spherical region called the Oort cloud, a swarm of icy bodies stretching perhaps up to 100,000 astronomical units. This is where comets are born. Occasionally, one is nudged inward by a passing star, or the pull of the galaxy's tides, beginning a long fall toward the inner solar system. When it approaches the Sun, its ice vaporizes, forming the glowing tails we see from Earth. Most of the time, though, these objects remain frozen in the deep dark, orbiting quietly for billions of years. The Oort cloud is so distant that no spacecraft has ever come close to it. It's mostly theoretical, inferred from the behavior of comets. If you could stand on one of its icy bodies, the Sun would be little more than a bright speck. The nearest stars would seem just as bright, and the boundary between our solar system and the galaxy would blur. Out there, the idea of a home system starts to lose meaning. Gravity still binds those objects to the Sun, but only faintly. The pull of other stars, or even the general mass of the Milky Way, can tug them away over time. The edge of our solar system isn't a wall, but a gradual fading of transition from the domain of one star to the shared gravity of many. The darkness that fills this space isn't something sinister. It's simply the absence of concentrated light. The energy here is diffuse, spread across unimaginable volumes. Yet even in that darkness, there's a subtle glow. Every star in the galaxy contributes to its faint, overlapping light that fills space with a kind of background brightness. If your eyes were sensitive enough, you'd see that glow as a soft haze like distant fog. It's the combined output of hundreds of billions of stars, too faint individually to see, but together forming a quiet ocean of light. That glow is what we call the Milky Way when we see it from Earth. From within, it's like being inside a vast, luminous cloud. Above and below, the galactic plane space extends outward for tens of thousands of light years. It's filled with ancient stars and clusters that formed early in the galaxy's history. These globular clusters orbit the center in long looping paths that carry them far above the disk before swinging back through it. They're relics of a time when the Milky Way was still forming, merging with smaller galaxies and gathering matter from its surroundings. The Sun's position in this larger structure is stable for now, but nothing in space stays fixed forever. Over the next 100 million years, the solar system will continue its slow orbit, passing through different parts of the galactic disk. Occasionally, it may encounter regions of higher density spiral arms, rich with gas and new stars, before moving back into quieter spaces. These passages could subtly influence conditions on Earth. The galaxy is vast, but its patterns still reach down to the scale of individual worlds. Thinking about our position this way, not as a static point, but as part of a moving system, changes how we see everything else. We often imagine ourselves as stationary observers watching the stars move around us. But in reality, we're the ones moving through their field. The galaxy doesn't turn around us. We travel within it, carried by its rotation, bound to its structure. Every sunrise, every orbit, every moment on Earth unfolds within that continuous motion. Even if we never feel it, we're in constant flight, gliding through the galactic sea along with billions of others. The farther we go beyond the planets, the more we realize that the solar system has no clear edge at all, only a continuous unfolding of scale. What once felt infinite becomes a small part of something larger. As you drift mentally beyond the last known objects of our solar system, the Sun behind you fades into the general starlight. Ahead lies the rest of the galaxy, a vast disk of stars stretching for 100,000 light years. From this vantage, the idea of beyond becomes relative. You haven't left anything behind. You've simply joined a broader field. The darkness around you isn't isolation, it's inclusion on a larger scale. In the middle of all that distance and darkness, everything we know still depends on a single star. It's so familiar that we rarely think of it as a star at all. We call it the Sun, and it's easy to forget that it's not unique, not rare, not even particularly large. Yet without it, nothing on Earth would exist. Not the oceans, not the air, not life itself. When we look up at it, we're not seeing an object in the sky. We're seeing the furnace that powers our entire world, the core of our local system, the quiet engine that's been burning steadily for more than 4 billion years. If you could see the sun from the same distance you see other stars, it would appear as just another faint point of light among billions. From a planet orbiting a nearby star like Alpha Centauri, it would look unremarkable, a modest yellow glow barely distinguishable from the rest. But from here up close, it fills our sky, floods our days with light, and defines the rhythm of our lives. Its energy shapes weather drives, wind and rain, and even influences our mood and health. The sun is both ordinary and irreplaceable, one of those contradictions that seem to define the universe. The sun is about 1.4 million kilometers across, more than 100 times wider than Earth. It contains 99.8% of all the mass in the solar system. Everything else, the planet's moons, asteroids, and dust, adds up to almost nothing in comparison. It's a sphere of plasma, not solid, but fluid, constantly churning. The temperature at its surface, called the photosphere, is around 5,500 degrees Celsius. That alone is unimaginably hot, but it's nothing compared to its core, where temperatures exceed 15 million degrees. In that central region, hydrogen atoms collide and fuse into helium, releasing energy that slowly works its way outward over thousands of years before escaping as light. Every photon that reaches Earth began as that slow chain of reactions deep inside the sun's heart. When that light finally leaves the surface, it travels through space at the speed of light, reaching Earth 8 minutes later. It arrives as a constant stream of energy enough to sustain every living thing, drive photosynthesis, and keep our planet's surface warm enough for liquid water. The sun is in every practical sense our only source of power. Even the energy stored in fossil fuels or wind or waves originates there. Every plant that grows, every storm that forms every current in the ocean owes its motion to the heat and light of the sun. It is quite literally the reason anything moves at all. And yet, for all its dominance, the sun is stable in a way that few things in the universe are. It doesn't flicker or pulse noticeably, doesn't vary much in brightness or heat. Its balance is almost perfect. The inward pull of gravity is matched exactly by the outward pressure of fusion. That equilibrium has held for billions of years and will continue to hold for billions more. It's the kind of stability that allows complexity to arise, the steady background against which life can evolve. If the sun were more erratic, brighter one year and dimmer the next, Earth's climate would swing wildly and our world might never have found balance. The sun's reliability is the quiet foundation of everything. When astronomers study it, they see not a flat disk, but a dynamic, restless surface. Massive loops of plasma arch into space along magnetic lines. Dark spots, cooler regions appear and vanish in cycles. Streams of charged particles escape into space as the solar wind flowing outward past the planets and eventually blending into interstellar space. The sun may look calm from a distance, but it's alive with movement. Its outer layers boil like water on a stove, convection cells, rising and falling in patterns so large they could swallow continents. Its atmosphere, the corona, extends millions of kilometers outward, invisible except during eclipses when its faint halo of light becomes visible around the moon's shadow. The sun's influence doesn't end with light. Its magnetic field stretches far into space, carried by the solar wind. That field shapes the environments of all the planets, bending and twisting as it interacts with theirs. When solar storms erupt massive bursts of energy from the sun's surface, they send waves of charged particles across the solar system. When those particles reach Earth, they collide with the magnetic field and atmosphere, creating auroras near the poles. Those shimmering curtains of light are visible reminders that we live under the constant influence of a star. Every flicker in the northern or southern sky is a trace of that connection, a silent conversation between our planet and its parent sun. If you could look inside the sun, you'd find that most of it is hydrogen with some helium and small traces of heavier elements. In its lifetime so far, it has converted a fraction of that hydrogen into helium through fusion. And in doing so, it's lost a small amount of mass, about 4 million tons every second, turned into energy by Einstein's famous equation. Even at that rate, the sun still has enough fuel to continue burning for roughly another 5 billion years. It's only at the end of that long life that things will change dramatically. When the hydrogen in its core runs low, the balance between pressure and gravity will shift. The sun will begin to expand, becoming a red giant. Its outer layers will swell outward, possibly engulfing Mercury and Venus, and maybe even Earth. Its surface will cool and redden, but its total brightness will increase. After a few 100 million years in that state, it will shed its outer layers entirely, leaving behind a dense hot core, a white dwarf, surrounded by a faint shell of glowing gas. The sun's light will fade gradually, but the remnants of its matter will persist, drifting through the galaxy, becoming part of something new. The same material that once made life possible on Earth will one day mix into clouds that form new stars and planets. That long future feels distant, but the process is already underway in slow motion. Every second the sun changes slightly, losing a little mass, shifting its balance, sending new waves of radiation through space. For us, the difference is invisible, but the scale of time makes every moment part of that larger evolution. The star we call home isn't static. It's a living system, aging in the quiet way that stars do. It doesn't need to hurry. It works on a timeline so long that even the rise and fall of civilizations is just an instant in its steady glow. It's remarkable that a sphere of plasma can sustain such order for so long. Stars, like the sun, are self-regulating. If fusion speeds up and the core gets too hot, pressure increases, causing it to expand slightly, which cools it and slows the reaction. If it cools too much, gravity compresses it, heating it up again. This delicate balance keeps the sun stable. It's a natural thermostat operating on cosmic scales. The laws that govern it are simple gravity, pressure, temperature. Yet the result is a structure capable of maintaining equilibrium for billions of years. The universe's complexity rests on the kind of stability, not chaos. From Earth, the sun appears to move across the sky, each day rising in the east and setting in the west. But that apparent motion is our own rotation, not the sun's. The sun itself rotates too, but much more slowly, once every 25 days at its equator, and more slowly near its poles. Its rotation twists its magnetic field over time, building up tension that eventually releases in solar flares and coronal mass ejections. The sun's behavior follows cycles roughly every 11 years, during which sunspot activity rises and falls. These cycles affect space weather, radio communication, and even climate patterns on Earth. The connection between our world and our star runs deeper than light alone. Even beyond its physical effects, the sun holds a place in human imagination unlike anything else in the sky. It's been worshipped, feared, measured, and painted since the beginning of civilization. Every culture has stories about it, gods of light and warmth, myths of rebirth and dawn. Long before we knew it was a star, we sensed its power. It governs the rhythm of life on Earth, sleep, growth, migration, and weather. Every plant leans toward it. Every animal adjusts its cycle to its rising and setting. Even our bodies follow its pattern through circadian rhythms, an ancient biological memory of sunlight. When we finally understood what the sun really was, it didn't diminish its wonder. Knowing that it's a fusion reactor 100 times wider than Earth, only deepened the awe. Science didn't make it smaller, it made it more intimate. The light that falls through your window each morning isn't abstract energy. It's the direct result of atoms fusing in the sun's core. It's part of a continuous flow of energy that has connected us to that star since the beginning of life. Every cell in every organism depends on it. The sun's rays drive photosynthesis, which in turn sustains the entire food chain. Even in the deep ocean, where sunlight never reaches the energy that feeds life, originates from processes powered by the sun's influence on Earth's surface. The sun is also our primary clock. Its position in the sky has guided timekeeping for as long as humans have measured time. Sundials, calendars, solstices, and equinoxes all trace back to its motion relative to Earth. The tilt of our planet's axis creates seasons, making sunlight stronger or weaker, longer or shorter through the year. Everything about our perception of time, the sense of days passing, years turning, is tied to how we orbit our star. Without that rhythm, life as we know it would lose structure. The sun gives time meaning by giving it variation. It's strange to think that this everyday light, this ordinary warmth, is the same kind of energy that fills the galaxy. The sun's spectrum of light is broad visible rays, infrared heat, ultraviolet radiation, and more. Some of it sustains life. Some of it can destroy it. The ozone layer around Earth filters the most harmful rays while letting through just enough to drive chemistry and warmth. In that balance again is the story of survival. Everything we know about life is built on finding equilibrium within the range of what the sun provides. Too little energy and the planet would freeze. Too much and it would burn. We exist in the narrow zone where light becomes life. Beyond Earth, the sun continues to shape the planets differently. Mercury is blasted by its heat. Venus, wrapped in thick clouds, traps that heat until its surface becomes hotter than an oven. Mars, too far out, receives less warmth, leaving it cold and dry. Each world's character is defined by how much sunlight it gets, how it retains or loses that heat. Even the gas giants, far beyond the warmth of the sun, feel its influence. Their upper atmospheres shimmer faintly in ultraviolet light, and their magnetic fields interact with the solar wind. The sun's reach extends across the entire system, defining the boundaries of everything we know. The solar wind that flows from it never truly stops. It continues outward, spreading through space, eventually merging with the interstellar medium. That flow carries with it a record of the sun's activity, its chemical signature, its rhythm, its changes. In a sense, the sun leaves a trail behind it as it moves through the galaxy, a faint wake of particles marking its passage. Everything that orbits it is part of that motion. We too are being carried along through the Milky Way at over 200 kilometers per second, following our star's path around the galactic center. From our perspective, the sun feels stationary. From the galaxy's perspective, it's a traveler tracing a slow orbit that takes hundreds of millions of years to complete. When we call the sun our star, we're claiming a kind of kinship that goes beyond geography. It's not just the center of our system, it's part of our identity. Every human who has ever lived has depended on its light measured time by its motion and found comfort in its warmth. We evolved under its rays. Our eyes are tuned to its spectrum. Our biology is synchronized to its rhythm. It is quite literally our environment in the deepest sense. Without it, we wouldn't just be cold, we wouldn't be possible. Even knowing that there are billions of other stars, it's hard not to feel something personal about this one. It's the star that lights our days, the one we see rise and set, the one whose energy pulses in every heartbeat. It connects the smallest details of life to the largest scales of the cosmos. From the fusion of hydrogen atoms to the flowering of plants, it's the same story continuing in different forms. The sun isn't just above us, It's within us, in the carbon, oxygen, and energy that make up our bodies. When you think about it that way, the idea of home expands. It's not just the earth beneath your feet, or even the solar system that surrounds us. It's the star at the center of it all. The constant presence that binds everything together. As our solar system moves through the galaxy, that star carries us with it, its gravity holding us in a fragile balance. We are passengers on its journey, protected by its warmth, powered by its light. When you step outside and look up, you're standing in the only place we know of that has managed to sustain awareness in a universe otherwise silent. That realization doesn't need to feel lonely. It can feel like belonging to something ongoing, a quiet process of matter becoming conscious of itself. The sun continues its work, patient and relentless, burning hydrogen into helium, sending light across empty space, warming a small blue planet where life can wonder about its own existence. And in that wondering, the sun becomes more than a star. It becomes ours. When you begin to think about how many stars exist beyond the sun, the numbers start to slip away from ordinary meaning. Our minds are built for counting things we can see or touch: apples in a bowl, cars on a road, people in a crowd. Even when we stretch that sense into the thousands or millions, it's still something we can picture. But the Milky Way is a place where counting stops working the way we expect. Here, the scale is so vast that the difference between 1 million and 1 billion becomes less a matter of arithmetic and more a matter of surrender. At some point, the brain simply gives up trying to imagine quantity and replaces it with wonder. Astronomers estimate that the Milky Way contains somewhere between 100 and 400 billion stars. The range is wide because no one can see them all directly. The galaxy is thick with dust that blocks our view, and many stars are too faint to detect with current instruments. What we can do is count a small patch of the sky, measure how many stars appear there, and then multiply by the number of similar patches that would fill the galaxy's volume. It's an approximation, but even the lowest estimates are staggering. Every point of light you see on a clear night is just one drop in a cosmic ocean, so deep that even light takes tens of thousands of years to cross it. When you look up at the sky without a telescope, you can see only about 5,000 stars with the naked eye under perfect conditions. Half of those are below the horizon at any given time, so in one view, you might see 2,000 or 3,000 at most. It's an impressive sight, but it's barely anything. In a galaxy of hundreds of billions, that's less than a fraction of a percent. The night sky looks crowded, but it's almost empty compared to what's really there. The visible stars are just the nearest and brightest our immediate neighbours in the galactic neighbourhood. Beyond them, the density increases invisibly each distant star, adding to the collective glow that forms the Milky Way's band across the sky. When early astronomers tried to count the stars, they ran into this problem quickly. Even with telescopes, the number grew too large and the instruments too limited. Each increase in magnification revealed more stars behind the ones already seen, as if the sky had no end. The deeper they looked, the more it seemed that the universe had no edges. Today, we can use automated surveys, powerful detectors, and computers to map vast sections of the galaxy. But the truth remains the same. The more precisely we count, the more countless it becomes. Every advance in technology expands the total rather than finishing the task. The galaxy seems to grow with our curiosity. It's not just the number of stars that's hard to imagine, it's their diversity. They come in all sizes, colours and lifespans. Most are smaller and dimmer than the sun, tiny red dwarfs that burn slowly for trillions of years. Others are massive and short-lived, shining so brightly that they use up their fuel in a few million years before collapsing or exploding. Between those extremes lies every possible variation: white, yellow, orange, blue, each with its own temperature, mass and character. Our star, so familiar to us, sits somewhere in the middle. It's not exceptional, just stable and comfortable part of the quiet majority that holds the galaxy together. When you look at the Milky Way in the night sky, you're seeing this collection of stars as a single band of light. The human eye can't distinguish individual points at that density. What appears as a smooth glow is actually billions of distant suns layered along the plane of our galaxy. Through a telescope, that hazy strip resolves into countless dots, each a separate world. Galileo was the first to describe this in detail. When he turned his small telescope toward the Milky Way, he wrote that it was nothing but a mass of innumerable stars. The word innumerable captures something important, not just quantity, but the recognition that the mind reaches a limit. There comes a point when numbers stop representing reality and start standing in for awe. If we could somehow see all the stars at once, the sky would never be dark. Every direction would shine. But most of those stars are too far, their light too faint, their energy scattered by dust and distance. That darkness we see between them isn't the absence of light, but the sum of too much light spread too thin. The universe is full, not empty, but it's full in a way that overwhelms rather than illuminates. The fact that we see darkness at all is a result of time and distance. Light takes time to travel, and space expands faster than light can fill it completely. We live in the balance between enough light to see and enough distance to leave room for shadow. When scientists measure the number of stars, they don't count individually. They measure mass. They know roughly how much matter the galaxy contains and how much of that mass is in stars. By dividing the total by the average stellar mass, they estimate the number. It's like weighing a forest instead of counting the trees. The result gives us a sense of scale, but not a picture we can hold. If we tried to count each star one by one, even at 1 star per second, it would take more than 10,000 years to finish. And by the time we were done, new stars would have formed, and old ones would have died. The galaxy doesn't wait for us to keep up. Among those billions of stars, many are bound together in systems. Roughly half of all stars are part of binary, or multiple systems, where 2 or more stars orbit each other. Some dance in pairs, others in clusters of dozens or hundreds. These systems form patterns of balanced gravity, shaping motion in intricate ways. Around them orbit planets, asteroids, and dust. Each star, no matter how faint, might have its own miniature solar system. In recent decades, we've confirmed thousands of exoplanets' worlds orbiting stars beyond our sun. And every discovery suggests there are far more waiting to be found. Statistically, there are likely more planets than stars in the galaxy. That means hundreds of billions of possible worlds, each unique, each spinning through its own story of light and gravity. When you realize that the idea of counting begins to shift, the goal stops being about numbers and becomes about understanding relationships, how stars form, how they die, how they cluster into arms and move around the galactic center. The Milky Way is structured but fluid, like a living organism. Stars are born in dense clouds of gas and dust. As they ignite, their radiation pushes away the surrounding material, shaping the next generation of formation. Over time, they drift apart, pulled by the collective gravity of the galaxy. Some stay close together, forming star clusters. Others wander alone. The process is continuous, a balance between creation and dispersal that keeps the galaxy alive. In our region of the Milky Way, one of the spiral arms called Orion's Cygnus stars are spaced on average a few light years apart. That sounds close, but it's still trillions of kilometers between neighbors. If the sun were the size of a marble, the next nearest star would be another marble placed several thousand kilometers away. Between them, nothing solid, only dust and darkness. Multiply that spacing by hundreds of billions, and you begin to glimpse the structure of the galaxy, mostly empty, but filled with light spread across impossible distances. The stars don't form a crowd. They form a vast network, each one a node connected by invisible threads of gravity and motion. The Milky Way's spiral arms are regions where those stars are denser, where the balance of gravity and rotation compresses gas clouds just enough to trigger new birth. They're like waves in the ocean patterns that move through material rather than fixed objects. Stars form within them, shine for a while, and drift out again, leaving room for the next generation. The spiral pattern we see from afar is the cumulative result of millions of years of movement. Counting stars isn't just counting points of light, it's counting motion process time. Each number represents something that has already changed, is changing, and will continue to change long after we stop observing. The way we map those stars depends on the light they emit. Some are visible, but many are hidden behind dust. To see them, astronomers use different parts of the spectrum: infrared, radio, X-ray, and more. Each wavelength reveals something different. Radio waves can pass through dust, showing stars in regions otherwise invisible. Infrared light reveals cooler objects like brown dwarf stars that never ignited fully. X-rays show the hottest, most energetic regions where matter is collapsing or exploding. By combining all these views, scientists build composite maps of the galaxy, layering colours of light we can't see into an image of the whole. It's a way of making the uncountable visible, if only in fragments. And yet every time we think we've mapped it, we discover something new. The European Space Agency's Gaia mission, for instance, is currently cataloguing over 1 billion stars with unprecedented accuracy, measuring their positions, brightness and motion. It's only a fraction of the total, but it's enough to create a living map of the Milky Way, a dynamic model where every star is tracked as it moves through space. From that data, astronomers can reconstruct the galaxy's history, tracing how it formed from smaller galaxies that merged billions of years ago. They can even predict its future, how it will change shape over the next few billion years as it interacts with its neighbours. Counting in this context becomes storytelling. The uncountable nature of stars isn't just about quantity, it's about time. Each star exists for millions or billions of years, going through stages of birth, maturity, and death. The galaxy isn't filled with identical lights. It's filled with processes at every phase of evolution. Some stars are newly formed, still wrapped in the gas clouds that created them. Others are middle-aged, like the sun, stable and steady. Still others are near the end of their lives, swelling into giants or collapsing into dense remnants. The light that reaches us carries all those ages, at once mixing them into a single view. When you look at the Milky Way, you're seeing history layered together, newborn light beside ancient echoes. Even the dark spaces between stars hold meaning. They're filled with molecules, hydrogen, carbon, monoxide, traces of more complex compounds, drifting and waiting for gravity to gather them again. Those clouds are the next generation of stars in waiting. The galaxy recycles itself endlessly. The atoms in your body, the calcium in your bones, the iron in your blood, all of them were forged in stars that lived and died long before the sun was born. Counting stars, in a sense, is counting the ancestors of everything that exists. Every one of those billions of points of light has contributed something to the material of life. When we describe the Milky Way as having hundreds of billions of stars, it's easy to focus on the number and forget the individuality. But each of those stars has its own story, its own path, its own potential for worlds, and perhaps even life. Somewhere out there, orbiting one of those countless suns, could be another planet with oceans, air, and people looking up and wondering the same things we do. If that's true, then the uncountable isn't just a matter of statistics, it's a measure of possibility, the vast range of what could exist, waiting quietly in the dark. That possibility reshapes how we think about our own smallness. If there are hundreds of billions of stars, and each might have planets, then there are hundreds of billions of chances for something like us to exist. Our place in the galaxy becomes less isolated and more like one instance in a grand pattern. The uncountable doesn't diminish our significance, it gives it context. We're part of a continuum so broad that the boundaries of meaning stretch beyond imagination. Every spark of light is both itself and a reflection of the whole. Trying to hold that scale in your mind for long can be dizzying. It's easy to lose sense of proportion, to feel the weight of distance and number pressing in. But there's also a kind of peace in it. Once you accept that the galaxy can't be counted in the ordinary sense, you can stop trying to reduce it to numbers and start letting it simply exist as it is vast, living, unmeasurable. The mind doesn't need to contain it to appreciate it. The act of wondering, of thinking about those countless stars, is itself a way of being part of the galaxy's unfolding story. So when we talk about counting the uncountable, what we're really doing is acknowledging the limit of comprehension and finding meaning beyond it. The galaxy doesn't ask to be tallied. It asks only to be seen, to be recognized as the environment that makes everything possible. Every atom, every light, every shadow belongs to it. The uncountable isn't a flaw in understanding. It's the natural state of something so large that even time and number bend under its scale. The galaxy isn't a static collection, but an ongoing process, one that continues, whether or not we keep track. Our role, small as it is to notice it, to learn from it, and to carry that awareness back to our own little corner of the sky, where a single star continues to shine, steady and familiar, among the uncountable others. When you look up at the Milky Way from Earth, what you see is only a fraction of its structure. To the naked eye, it appears as a pale, irregular band stretching across the sky. In photographs, it becomes a luminous arc, filled with subtle color and texture, a river of light winding through darkness. But what we see from within is only the cross-section of a much larger form, a spiral galaxy seen edge-on from the inside. From our position, about halfway between the center and the edge, we look through the densest part of its disk. Every faint shimmer, every cluster, every hazy patch in that band is part of the same enormous structure, turning slowly through space. The Milky Way isn't a solid object. It's a vast collection of stars, gas, dust, and dark matter held together by gravity and shaped by motion. Its spiral form is not a rigid shape, but a pattern, the result of billions of individual orbits, each following its own path, yet together, creating the illusion of arms that curl gracefully outward. The galaxy is about 100,000 light years across and roughly 1,000 light years thick. It contains not only stars, but also immense clouds of hydrogen filaments of dust and invisible halos of dark matter that extend far beyond what we can see. All of it moves in a slow, coordinated rhythm around the galactic center. From the outside, it would look like a flat disk with a bright bulge in the middle where stars are densely packed. Surrounding that disk is a faint halo, a diffuse sphere of old stars and clusters orbiting far from the core. The spiral arms extending outward from the center are regions of higher density where new stars are born. They're not static structures. They move through the disk like waves of compression, gathering gas and dust as they pass. Inside those arms, stars ignite, live their lives, and drift away, leaving the pattern to repeat. The Milky Way's gentle spiral is both movement and memory, a pattern that persists even though the material within it constantly changes. We can't see the whole structure directly because we're inside it. It's like trying to describe the shape of a forest while standing among the trees. Our view is limited to what we can measure and infer. Over time, astronomers have pieced together the picture using radio telescopes that can detect the faint emission from hydrogen gas. By mapping the motion of that gas, they've traced the spiral pattern of the arms. We now know that the Milky Way has a central bar, a stretched, dense region of stars that cuts across the core, and from the ends of that bar, several major spiral arms emerge. Our solar system lies within one of the smaller arms, called the Orion Cygnus arm, nestled between two larger ones, named Sagittarius and Perseus. When you imagine the galaxy from above, the spiral arms look like slow turning currents in a vast whirlpool. Each arm contains countless clusters, nebulae, and star-forming regions. They're not rigid or sharply defined. They fade gradually into the spaces between where the density of stars decreases, but never reaches zero. The Milky Way's rotation is not uniform either. Stars closer to the center orbit faster, while those near the edges move more slowly. This difference in speed is part of what maintains the spiral structure, a dynamic balance between motion and gravity. It's a kind of self-organizing beauty, a shape that sustains itself through movement rather than design. At the heart of the galaxy lies the bulge, a dense region packed with old stars and dust. It's not spherical, but elongated like the core of a seed. Buried within that bulge is something we can't see directly, a supermassive black hole known as Sagittarius A star. It has a mass equivalent to about 4 million suns, yet it occupies a region no larger than our solar system. Its gravity is so strong that even light cannot escape, but we can detect its presence by watching how nearby stars move. They orbit the invisible center at incredible speeds, their paths revealing the weight of something immense hidden in the dark. Sagittarius A star is quiet most of the time, feeding slowly on surrounding material, but occasionally it flares, releasing bursts of energy that ripple through space. The discovery of that black hole changed how we understand galaxies. It seems that nearly all large galaxies have such a massive object at their core. The relationship between these central black holes and the galaxies that surround them is still a mystery. They might grow together, influencing each other's evolution over billions of years. The center of the Milky Way, though distant and obscured by dust, is a place of intense activity, stars packed so closely that they orbit within hours, clusters colliding, clouds of gas collapsing under pressure. It's a region that reminds us that even in the quiet, ordered spiral, there are places of chaos and energy. Farther from the core, where our solar system resides, the galaxy is calmer. Here the stars are more widely spaced, and the spiral arms sweep through slowly, taking hundreds of millions of years to complete one turn. The Sun itself orbits the center at a distance of about 26,000 light years, moving at roughly 200 kilometers per second. At that speed, it takes about 230 million years to make a full revolution. That means, since the formation of the solar system about 4.5 billion years ago, we've circled the galaxy roughly 20 times. Every orbit carries us through different regions, denser arms, quieter gaps, clouds of dust and open star fields. Our view of the sky changes slowly over geological time, though to us it feels fixed. The Milky Way's disk isn't flat, like a record. It's slightly warped, its edges curling up and down in a gentle wave. This warp may have been caused by gravitational interactions with smaller galaxies orbiting nearby, or by the uneven pull of dark matter surrounding it. The disk also vibrates subtly, like the surface of water, disturbed by distant motion. These ripples move through the stars and gas, over millions of years, shaping patterns we can only detect through careful measurement. Even at the galactic scale, motion never truly stops. The spiral arms, the stars, the gas clouds, all of it participates in a constant slow dance governed by gravity's patient hand. When you consider the sheer number of stars and the size of the structure that contains them, it's easy to think of the galaxy as static, something too large to change. But it evolves constantly. Stars form in the spiral arms, live their lives, and die, enriching the surrounding gas with heavier elements. Supernovae explode, scattering material that will one day form new stars and planets. The cycle repeats endlessly, each generation building on the remnants of the previous one. The Milky Way spiral isn't just a shape, it's a process, a record of creation stretching across billions of years. If you could somehow rise above the disk and look down from a distance, the Milky Way would glow with a soft diffuse light. Its arms would wind outward like trails of smoke, bright near the center and fading toward the edges. From that vantage, you could see its neighbors too small, satellite galaxies like the large and small Magellanic Clouds orbiting nearby, drawn slowly inward by gravity. You might even see faint streams of stars, remnants of smaller galaxies that the Milky Way has absorbed in the past. Over its long history, it has grown by consuming others, their stars stretched into thin arcs that still circle the outskirts. The spiral we see today is partly the result of those interactions, a blend of order and memory written in starlight. Inside the disk where we are, perspective changes everything. The spiral arms we imagine as sweeping curves appear to us as dense regions of stars along the plane of the sky. When we look toward the galactic center in the direction of Sagittarius, the sky becomes crowded with light, the Milky Way at its brightest. When we look away toward the outer edge, it thins into a faint shimmer. Between those extremes, dark lanes of dust cut through the glow like rivers of shadow. These are the same clouds that will one day form new stars. They block visible light, but shine faintly in infrared revealing structure, even in the places that look empty. It's in those dense lanes and glowing arms that we see the galaxy's balance, most clearly destruction and creation existing side by side. A supernova explosion can sweep clean a region of gas, but the shock wave from that event can also compress nearby clouds, triggering the birth of new stars. The Milky Way sustains itself through that cycle. Nothing is truly lost. It's all transformed, moving from one form to another in the slow rhythm of galactic time. From the perspective of a single lifetime, it seems eternal. From the perspective of cosmic history, it's as transient as anything else, one of billions of galaxies each, with its own brief story in the lifespan of the universe. We sometimes imagine the spiral arms as static pathways, but they're more like waves, traveling through a sea of stars. As those waves move, stars drift in and out of them. A star born in one arm may live long enough to move into another, or into the space between. The arms persist, not because the same stars remain, but because new ones keep forming to replace them. It's a bit like traffic on a busy highway. The cars change constantly, but the pattern of motion remains. This is why the Milky Way's spiral form endures, even though every star within it moves independently. The rotation of the galaxy also reveals something in visible dark matter. When scientists measured how fast stars orbit at different distances from the center, they expected those farther out to move more slowly, just as planets in the solar system do. But they found that the speed stayed nearly constant even at great distances. That meant there had to be more mass. Then we could see something that doesn't emit or reflect light, but still exerts gravity. This unseen material, called dark matter, forms a vast halo around the galaxy, outweighing all the visible stars and gas combined. We don't know what it's made of, but without it, the Milky Way's gentle spiral would not hold together. It would spin apart. The shape we see depends on something invisible, an unseen scaffold that keeps the galaxy intact. Even with all our instruments, the full picture remains incomplete. We can map the arms, measure the rotation, and model the structure, but much of the detail is still hidden by distance and dust. The galaxy's far side opposite our position is difficult to observe directly. We know it's there from symmetry and from faint radio signals, but it remains largely unseen. In that sense, we live in a place both known and mysterious, familiar enough to understand, but vast enough to remain beyond full comprehension. The Milky Way's spiral is gentle not only in shape, but in its refusal to reveal everything at once. Thinking about this structure while lying under the night sky can make the mind feel weightless. Every point of light is part of the same rotating disk, and we are inside it, moving with it. The stars that appear fixed are actually tracing slow orbits around the galactic center. The sun's path carries us through arms and inter-arm regions, through clouds of gas and fields of empty space. The entire solar system is like a small passenger on one of the outer lanes of an immense carousel, moving smoothly and silently in a motion too grand to feel. There's no vibration, no noise, no friction, just the steady drift of everything in unison. If you could watch the Milky Way's rotation sped up to a human pace, you'd see it turn gracefully, the arms winding and unwinding stars, lighting up and fading away. It would look alive, breathing in cycles of light. But at normal speed, those changes unfold over spans of time far longer than human history. The galaxy's spiral, for all its grandeur, is a picture of patience, its motion stretched across eons so slow that it becomes invisible and yet constant enough to define the background of everything that happens here. When you think about how many generations of stars have lived and died within those arms, it becomes clear that our existence is woven into that long process. The atoms in your body, the carbon, nitrogen, and oxygen, were formed in stars that once shone somewhere in the Milky Way's spiral. They lived, burned, exploded, and scattered their elements into space, where they eventually became part of the cloud that formed the sun and the planets. The spiral isn't just the structure of our galaxy, it's the history of everything that has ever existed here. It's the path through which matter cycles, the shape through which time itself seems to move. As we continue to observe and map it, the Milky Way's spiral remains one of the most familiar yet unreachable forms in the universe. We can describe it, model it, even imagine standing outside it, but we'll always see it from within, surrounded by its light. That vantage point defines our perspective, close enough to feel its pull, distant enough to never see it whole. And perhaps that's fitting. A complete view might leave no room for wonder. Seeing only a part allows imagination to fill the rest. If you look up tonight and the sky is clear enough to see that faint river of light stretching across the darkness, you're looking through one of those spiral arms. You're seeing the shape of the galaxy from the inside, an edge-on glimpse of the structure that holds us all. The light you see has traveled for thousands of years, crossing the space between stars to reach your eyes. Each photon carries the signature of its origin, a reminder that we're part of a system so large and so smooth that even the smallest motion connects to something vast. The spiral continues to turn indifferent to our sense of time, drawing us with it through the quiet geometry of the Milky Way. And as we drift with it, we remain surrounded by that same gentle structure, the luminous arms that guide our path through the galaxy, the subtle motion that never stops, and the unspoken rhythm that binds every star, planet, and molecule of dust into the same cosmic curve. When we try to describe where we are in the universe, it's natural to start small. We live on a planet that orbits a star. That star belongs to a galaxy we call the Milky Way. But the moment you try to expand that sentence beyond those simple facts, the scale begins to slip out of reach. Even describing our location within the galaxy requires language stretched beyond what our senses were designed for. The Milky Way is so vast, so layered, that to find our exact place within, it feels a little like trying to describe a single grain of sand on an endless beach. Still, there is something quietly grounding about knowing that we can locate ourselves at all, that our small world has a definable address in the great galactic sea. Our solar system is situated in one of the Milky Way's minor spiral arms, a region known as the Orion Cygnus arm. It's not one of the major arms like Sagittarius or Perseus, which sweep outward from the galactic center in grand arcs. Instead, it's more like a smaller bridge of stars that runs between them, a calm stretch of the galaxy's disk, with enough stability for planetary systems to thrive. You can imagine it as a quiet lane in a busy city, far enough from the dense downtown of the galactic core to avoid its chaos, but close enough to feel part of the structure. This small arm is our neighborhood, the region of the Milky Way, where the sun was born, and where it has been traveling for billions of years. If you could see the galaxy from above, our position would be about 2/3 of the way out from the center, roughly 26,000 light years away. That might sound close in the context of the galaxy's size, but light itself takes 26,000 years to cross that distance. In more familiar terms, it's around 250 quadrillion kilometers. These numbers are so large, they stop feeling like numbers at all. They become markers of proportion, a reminder that the sun, the planets and everything that has ever happened on Earth exists within a small pocket of space, halfway along one of the galaxy's spiral arms. We orbit the galactic center at a speed of about 220 kilometers per second. Even at that pace, it takes more than 200 million years to make a single revolution. Since the solar system formed, we've completed only about 20 full orbits. Every time Earth goes around the sun itself has moved slightly along its own path through the galaxy. We're never in the same place twice. The stars that appear fixed in the sky are moving too, each tracing its own slow curve around the galactic core. The patterns we call constellations are temporary alignments, meaningful only on the scale of a few thousand years. On the scale of the galaxy, they drift apart like clouds. The space around us is not empty. It's filled with stars, dust and gas, though spread so thin that even the nearest stars are separated by light years of distance. The nearest major star to the Sun, Alpha Centauri, lies about 4.37 light years away. Between us and it lies a vast region of space containing only a handful of atoms per cubic centimetre. And yet that same region is part of the continuous fabric of the galaxy. The light that leaves our sun travels through it, blending with the light from other stars, filling the space between them with a faint collective glow. The galaxy's disk is like an ocean of light and matter, dense near the center and sparse near the edges, but continuous throughout. When we say that we live in the Milky Way, it's more accurate than it sounds. The sun and its planets orbit within a thin disk about 1,000 light years thick. Most of the galaxy's stars, gas and dust, are contained within that disk. Above and below it, the density drops quickly, giving way to the galactic halo, a vast diffuse region populated by older stars and globular clusters. The disk itself is slightly warped, curving upward on one side and downward on the other. From our vantage point, we lie close to the midplane, not exactly centered, but well within the main body of the galaxy. The environment here is relatively calm compared to other regions. The density of stars is low enough that the gravitational influence of nearby suns doesn't disturb the stability of planetary systems. That calmness is one of the reasons life could develop on Earth. Closer to the center of the galaxy, stars are packed so tightly that their radiation and gravitational interactions create a far more volatile environment. Farther out beyond the spiral arms, the density drops so much that there may not be enough heavy elements for planets to form. Our position between the extremes is something astronomers sometimes call the galactic habitable zone. It's not an official boundary, but it describes a region where conditions are just right, not too crowded, not too sparse. From within the disk, we can't see the galaxy's full shape directly, but we can infer it from the way stars move. The sun and nearby stars orbit the center in nearly circular paths, guided by the combined gravity of everything in the galaxy, stars, gas dust, and the unseen dark matter that forms its invisible halo. That halo extends far beyond the visible edge, providing most of the mass that keeps the spiral structure intact. Without it, the outer regions would spin apart. Our orbit, though fast, is steady part of a balanced motion that has persisted for billions of years. The galaxy's gravitational field is strong enough to hold us, but gentle enough to let us move freely within it. The region around the Sun is sometimes called the local bubble, a cavity in the interstellar medium, created long ago by supernova explosions. The gas here is thinner and hotter than in surrounding areas, suggesting that a series of ancient stellar deaths cleared out the space around us. The Sun happens to reside near the edge of this bubble, in a region where the density of interstellar gas is beginning to rise again. It's likely that as we continue our orbit, the solar system will eventually drift into denser regions of the galaxy, encountering new clouds of gas and dust. On a human timescale, that journey is imperceptible, but over millions of years, it will subtly change our environment. Our address within the Milky Way, if written out, would sound like something halfway between a poem and a scientific coordinate. The third planet, orbiting a G-type main sequence star located in the Orion Cygnus arm of the Milky Way galaxy, approximately 26,000 light-years from the galactic center, moving at 220 kilometers per second through the galactic disk. It's factual, but it's also a description of belonging. It tells us not only where we are, but how we move, a reminder that our position is not static, that we are part of an ongoing flow through the galaxy's structure. It's easy to think of the Milky Way as an external object, a vast thing that we're observing from the outside. But we are inside it completely. Every direction you look, you're looking into the galaxy. Even the empty parts of the sky are filled with its faint light, its distant stars. The galactic center lies in the direction of the constellation Sagittarius. And if you could see through the dust that blocks visible light, you would find an overwhelming brightness there. Radio and infrared observations reveal the crowded heart of the galaxy, dense clusters of stars, clouds of gas glowing with energy, and the gravitational dominance of the central black hole. In the opposite direction, toward the constellation Auriga, you look outward toward the galaxy's edge, where stars grow fewer and darkness takes over. Knowing our place within that layout helps us understand the view we see each night. When the Milky Way arches across the sky, we're looking through the plane of the disk, our line of sight cutting through layers of stars. The densest parts correspond to where we're looking toward the center, while the thinner regions are where we look outward. That's why the band appears brighter in one direction and dimmer in another. We're seeing the galaxy's structure not as a whole, but as a cross-section, an interior view of our own home. If you could travel far above the disk, you'd see the Milky Way as a flattened spiral, its arms winding outward from the glowing center. From that perspective, our solar system would be invisible to the eye, even with the best telescopes. The sun's light would blend into the general glow, indistinguishable from billions of others. Yet within that vast field of light, everything familiar, every tree, ocean, and thought would still be there, carried along on one small dot, orbiting one ordinary star. Our sense of scale might vanish from such a distance, but our sense of continuity would remain. No matter how far you move away, the galaxy's light would still include ours, faint but present. Around us, within a few dozen light years, lies what astronomers call the solar neighborhood. It includes nearby stars like Alpha Centauri Sirius, Epsilon Eridani, and Procyon. Many of these have their own planetary systems. From their vantage point, our sun would appear as just another bright star, a modest yellow point among many. The idea that each of those stars, might have its own worlds, its own forms of light and shadow, gives our neighbourhood a sense of quiet depth. The galactic sea is not empty between its major currents. It's filled with islands of light, each with its own system, its own rhythm, and its own history. The scale of that sea becomes clearer when we look at the distribution of stars. Near the galactic centre, they are densely packed thousands per cubic light year. Out here near the edge of one arm, the average distance between stars is several light years. That spacing creates the illusion of isolation, but it's also what makes our region stable. Fewer close encounters mean less disruption over billions of years. That stability has allowed planetary systems to remain intact long enough for life to develop. We exist not because we are at the center of anything, but because we are far enough from chaos to endure. Above and below the galactic plane, the halo of the Milky Way extends outward for tens of thousands of light years. It's filled with ancient stars and clusters that formed early in the galaxy's history. These globular clusters orbit the center in long looping paths that carry them far above the disk before swinging back through it. They're relics of a time when the Milky Way was still forming, merging with smaller galaxies and gathering matter from its surroundings. Some of those early collisions left streams of stars that still trace arcs through space, faint reminders of the galaxy's ongoing evolution. The Sun's position in this larger structure is stable for now, but nothing in space stays fixed forever. Over the next 100 million years, the solar system will continue its slow orbit, passing through different parts of the galactic disk. Occasionally, it may encounter regions of higher density spiral arms rich with gas and new stars before moving back into quieter spaces. These passages could subtly influence conditions on Earth. Some scientists speculate that as we move through regions with more interstellar dust, the influx of cosmic particles might affect climate or evolution. The galaxy is vast, but its patterns still reach down to the scale of individual worlds. Thinking about our position this way not as a static point, but as part of a moving system, changes how we see everything else. We often imagine ourselves as stationary observers watching the stars move around us, but in reality, we're the ones moving through their field. The galaxy doesn't turn around us, we travel within it, carried by its rotation, bound to its structure. Every sunrise, every orbit, every moment on Earth unfolds within that continuous motion. Even if we never feel it, we're in constant flight, gliding through the galactic sea along with billions of others. The term galactic sea is fitting because the Milky Way behaves like an ocean. Its stars are like waves, rising and falling in patterns that repeat but never stay the same. The currents are gravitational, flowing between clusters and arms, guided by the mass of dark matter beneath. We're a small part of that movement, floating on a current we didn't create and can't control, but that carries us all the same. The sense of being at home within something so large comes not from knowing every detail, but from realizing we belong to the motion itself. If you imagine standing on a distant planet orbiting a star in another arm of the Milky Way, our position would seem almost identical to theirs. A small point in the disk midway between the center and the edge, moving through the same slow rotation. From that perspective, the idea of an address becomes relative. There are no fixed coordinates in a galaxy that's always in motion, only relationships between moving parts. What we call location is really participation, the specific place where our motion intersects with everything else. The beauty of knowing our galactic address is that it gives scale to our perspective without shrinking it. We are small, yes, but not misplaced. We occupy a stable orbit in a quiet arm of a spiral galaxy that has existed for more than 10 billion years. Everything we know fits into that context, a single system among billions, each one contributing its own light to the whole. It's not a position of insignificance, but of integration. We are part of the pattern, shaped by it, sustained by it, and destined to move with it through time. And as we continue along that path, the view will shift slowly and visibly. The constellations will change, new stars will appear as old ones fade. The galaxy's arms will rotate and will pass through them again and again, carried by the same invisible current. Every orbit adds another layer to our story, another turn in the quiet spiral of motion that defines the Milky Way. Somewhere within that slow rhythm, we remain anchored a small solar system in the Orion Cygnus arm, circling the galactic center, surrounded by stars and dust and light. That's our address, our location in the great sea of the galaxy. And while we'll never see it from the outside, we can still sense it every time we look up and realize that every point of light above us is part of the same vast home turning silently through space. When we try to imagine the distances that exist beyond Earth, it quickly becomes clear that ordinary intuition doesn't work. Our minds are built for the scale of daily life meters, kilometers, maybe thousands of kilometers, if we think about continents or oceans. Those are distances we can picture because we can cross them, measure them, and see their edges. But when we step beyond the boundaries of our planet, those familiar anchors disappear. The space between worlds, between stars, between galaxies, expands so far beyond our senses that the words we use to describe it lose meaning. Even numbers precise as they are start to feel abstract, like symbols for something the human mind was never meant to hold. To begin understanding that scale, it helps to start small, or at least small, by cosmic standards. The Earth is about 12,700 kilometers across. The Moon is nearly 400,000 kilometers away. It takes light a little more than a second to cross that gap. That already feels large, and yet the distance between Earth and the Sun is 300 times greater. We call that span one astronomical unit about 150 million kilometers. And even that is still tiny compared to the rest of the solar system. Neptune, the outermost of the major planets, is 30 astronomical units from the Sun. It takes light over 4 hours to reach it, from the Sun to the edge of the solar system, where the influence of its wind fades into interstellar space, is more than 100 astronomical units. Beyond that lies the Oort cloud, a shell of icy bodies that stretches perhaps 100,000 astronomical units in every direction. At that distance, the Sun's light takes more than a year and a half to reach the outer edge. The boundary between the solar system and interstellar space isn't a line, it's a gradient of fading influence. When you consider those scales, it becomes obvious why the distances between stars are so hard to imagine. The nearest star system, Alpha Centauri, lies more than 4 light years away, 40 trillion kilometers. Compared to that, even the vastness of the solar system looks compact. A light year is the distance light travels in 1 year, about 9.46 trillion kilometers. It's a unit that replaces impossibly large numbers with a smaller word, but it doesn't make the reality any easier to grasp. When astronomers say a star is 10 light years away, they mean its light has been traveling toward us for 10 years. 100 light years means 100 years of travel at the fastest possible speed in the universe. And that's still nothing compared to the size of the galaxy. The Milky Way is about 100,000 light years across. Light leaving one edge will take 100,000 years to reach the other. Every time you see the faint band of the Milky Way across the sky, you're looking through that immense distance, a field of light so large that even at the speed of light crossing, it would take longer than all of recorded human history. The problem with thinking about such distances is that we naturally try to visualize them. We imagine traveling from one point to another as if space were a landscape we could cross. But the scale defeats that approach. No vehicle, no technology we've built or imagined can come close to the speed needed to make such journeys reasonable. The Voyager spacecraft. The most distant human-made objects are still within the outer edges of the solar system after almost 50 years of travel. They're moving fast by any normal standard, about 60,000 kilometers per hour. But at that speed, they would need more than 70,000 years to reach the nearest star. It's not that the galaxy is unwelcoming, it's simply enormous in a way that makes motion itself seem slow. If you tried to build a model of the solar system that fit into something you could walk across, you'd quickly run into problems of scale. Suppose you made the Earth the size of a marble, about 1 centimeter across. On that scale, the Moon would be a smaller bead a few centimeters away. The Sun would be a ball more than a meter across, about 100 meters away from the Earth. The outer planets would be scattered across a space several kilometers wide, and the nearest star it would be another meter-wide sphere, placed more than 2,000 kilometers away. Between them, nothing but emptiness. This is what makes space so difficult to comprehend. Our everyday experience teaches us that distance is defined by things: roads, oceans, mountains, places to stop. But most of the universe is not made of things, it's made of space itself. The distances are not filled with matter, not populated by objects, but open. The fraction of the galaxy occupied by stars, planets, or dust is almost zero compared to the vastness of the gaps between them. The Milky Way, though dense with hundreds of billions of stars, is mostly vacuum. If the Sun were the size of a coin, the nearest other star on that scale would be another coin placed tens of thousands of kilometers away. The space between them would be empty enough to fit millions of other coins without a single collision. Even within galaxies, the distances between stars are so large that their light rarely meets. Photons travel freely through the interstellar medium, occasionally scattered by dust, but mostly unimpeded. That's why we can see stars at all. If space were crowded, their light wouldn't reach us. The emptiness is what makes the view possible. The Milky Way's soft glow in the night sky is a collective illusion, countless stars seen together from a great distance. They seem close because their light overlaps, but they are separated by light years of emptiness. We've developed ways to measure these distances, though even our tools strain against the scale. For nearby stars, astronomers use parallax, the apparent shift in a star's position as Earth moves around the Sun. By measuring that tiny angle, they can calculate the star's distance. The effect is so small that even for the nearest stars, the shift is barely detectable. For example, Alpha Centauri's parallax is less than 1 arcsecond, about the same as seeing a coin move 1 centimeter when viewed from several kilometers away. For more distant stars, parallax becomes too small to measure directly, and we rely on brightness and spectral characteristics instead. We compare the observed light to what we expect from similar stars and infer distance from how faint it appears. Each method adds a layer of approximation, and yet, through patient measurement, we've mapped the galaxy with remarkable accuracy. When we extend our view beyond the Milky Way, the numbers grow even harder to hold. The nearest large galaxy, Andromeda, is about 2.5 million light years away. That means the light we see from it tonight left before the earliest humans walked the Earth. The galaxies we see at the edge of the observable universe are so far away that their light has been travelling for more than 13 billion years. We're not seeing them as they are, but as they were when the universe was young. The space between us and them has expanded since that light began its journey, stretching the light's wavelength and dimming its colour, an effect we call redshift. Every distant galaxy is both a picture of the past and a measurement of distance written in colour. Distances like these change how we think about time. When you look at the stars, you're looking back into history. Even the light from the sun is 8 minutes old. From Sirius, it's 8 years. from the Pleiades about 400. When you look at Andromeda through a telescope, you're seeing a galaxy as it was when the first fires burned in human settlements. Time and space blend together so completely that it becomes difficult to separate them. Every point of light in the night sky is also a point in the past. The farther you look, the older the image. This connection between distance and time isn't just poetic, it's physical. The speed of light is the ultimate limit. Nothing can move faster. That means information itself is bound by distance. We can't see the present state of faraway objects, we can only see their past. Even if a distant star exploded right now, we wouldn't know until its light reached us, possibly centuries later. The universe is a network of delayed signals, each place seeing every other as it was long ago. The closer you are, the more current your view. The farther you go, the older the picture becomes. In that sense, the cosmos is both vast and full of memories carrying light from moments that ended long before we were here to witness them. When we measure these scales, the numbers themselves can lose meaning. It's easy to say a light year or a parsec, but each one represents a physical span that's incomprehensible without context. To give perspective, the fastest spacecraft ever launched by humanity, traveling at tens of kilometers per second, would take tens of thousands of years just to reach the nearest star. The diameter of our galaxy, measured in light years, would take hundreds of millions of years to cross at that speed. The nearest large cluster of galaxies, the Virgo cluster, is more than 50 million light years away. These are distances so great that even at the speed of light, communication between such regions would take longer than the lifespan of entire species. Because of this, the universe we see is always only a small local version of the whole. The observable universe, the part from which light has had time to reach us since the Big Bang, is about 93 billion light years across. Beyond that, space continues, but we can never see it. Light from those regions hasn't had enough time to arrive. The horizon of visibility isn't the edge of reality, it's the edge of information. We're inside a bubble, defined not by walls, but by time itself. Even within that bubble, distances defy ordinary comparison. Between the planets we measure in millions of kilometers. Between stars in light years. Between galaxies in millions of light years. Between clusters of galaxies in hundreds of millions. Each step up in scale adds zeros so quickly that perspective collapses. The human mind wasn't built for such quantities. We evolved to navigate valleys, not voids. But through mathematics and imagination, we can extend our sense of place, building conceptual bridges across scales we'll never physically cross. There's something strangely peaceful about that realization. The sheer size of the universe doesn't make us small in the way we sometimes fear. It makes us part of something continuous. The same laws that govern falling apples and orbiting planets also govern the motion of galaxies. Gravity doesn't care about scale. Light behaves the same way, whether it travels across a room or across a galaxy. The distances may defy intuition, but the principles remain steady. That continuity links us to everything else, making the impossible size of the universe feel less alien and more like an extension of what we already know, stretched beyond sight. Sometimes astronomers use analogies to help make these distances feel less abstract. They might describe the galaxy as a city where each star is a house and the spaces between them are miles of empty land. Or they might compare the observable universe to the surface of a balloon expanding where galaxies are like dots on its skin, carried farther apart as the balloon inflates. These comparisons don't capture the full reality, but they give a sense of motion and scale that our everyday experience lacks. They remind us that distance isn't just static space. It's dynamic, shaped by time, motion, and gravity. Even in the emptiest reaches of the universe, there is structure. Galaxies cluster together, forming filaments that stretch across hundreds of millions of light years. Between them lie vast voids regions where almost no galaxies exist at all. The pattern resembles a web, a cosmic lattice of light and darkness. Our own Milky Way is part of one of those filaments connected to neighboring galaxies through invisible threads of gravity. The spaces between clusters are so large that entire galaxies could drift through them without ever meeting another for the lifetime of the universe. These are distances that can't be walked, flown, or even meaningfully imagined, only calculated and acknowledged. It's tempting to think that such vast separations make the universe disconnected. But in reality, those gaps are part of its structure. The expansion of space itself creates them. Everything we see, every star, every galaxy moves away from every other one. The distances grow, not because things are moving through space, but because space itself is stretching. The farther apart two galaxies are, the faster they appear to move away from each other. It's not motion in the ordinary sense, it's the fabric of the universe, expanding everywhere at once. That's why there's no true center. Every point can be considered the middle, because the expansion happens uniformly in all directions. When you realize this, the word distance takes on a new meaning. It's not just a measure between two objects, it's a measure of time, expansion, and change. Every span between stars or galaxies carries a history of movement. The light that crosses those spans brings information from one moment to another, turning the universe into a kind of record. The vastness we can't imagine isn't empty or static. It's full of relationships written in light and gravity stretched across time. Even though we can't intuitively feel these distances, we can still measure them, describe them, and use them to understand our place. We can point to a galaxy millions of light years away and know that its light has traveled for eons to reach us. We can trace the curvature of space itself and see how matter bends light over cosmic scales. Through observation, the unimaginable becomes measurable. We may never truly comprehend what 100,000 light years feels like, but we can still know what it means. That's what science offers, not comfort through familiarity, but clarity through understanding. So when you look at the night sky and see the faint, scattered stars, remember that the light reaching you has crossed distances that defy every human sense of scale. It has traveled through regions so vast and empty that even words like space seem too small. Each glimmer is a signal from a different time, a reminder that we live within a structure of distances so immense that they become their own kind of silence. And yet within that silence, there's order, motion, and connection, the quiet geometry of the universe, continuing endlessly beyond the limits of intuition. Even when everything appears still, nothing in the universe is truly at rest. The world beneath you turns quietly, carrying you through day and night. The planet orbits the sun at 30 kilometers every second. The sun itself moves through the galaxy at hundreds of kilometers per second, and the galaxy in turn drifts through the larger structure of the universe, carried along by gravitational currents that never stop. The stillness we feel is only relative. Motion is constant, continuous, and everywhere. It's so vast and smooth that we never notice it. The air doesn't rush past us. The ground doesn't tremble beneath our feet. But we are always in motion, part of a silent drift that extends from the smallest particles to the largest structures in existence. If you could somehow stop everything else and look at the solar system from far away, you'd see it moving like a small bead following a track. The sun leads, and the planets orbit it all together, traveling around the center of the Milky Way. The path isn't a perfect circle, but a slightly elliptical arc, tilted and curved within the galactic disk. Every object within that system, Earth, the Moon, the asteroids moves together in a synchronized glide. Nothing stands still, yet everything maintains its position relative to the whole. The balance is so stable that the same orbits have persisted for billions of years. This motion around the galactic center defines much of our existence, even though it's completely invisible to us. The sun travels at roughly 220 kilometers per second, and yet we feel nothing because there's no resistance. Space offers no drag, no friction, no air to push against. In this vacuum, motion is silent and perfect. The Earth, the planets and the sun all fall together under the pull of the galaxy's gravity, circling an unseen center, where billions of other stars are also in orbit. The result is a kind of cosmic calm, constant movement without turbulence. If you could look down on the Milky Way from above, you'd see stars tracing elegant spirals, each one moving at its own speed, but maintaining a collective rhythm. The galaxy rotates once every 230 million years. And though that may seem slow, the distances involved are so great that the motion adds up to immense speeds. Every star participates in that rotation, each orbiting the same gravitational center, but never colliding. The space between them is wide enough that even as they move in vast numbers, direct contact almost never happens. It's a quiet traffic pattern on a scale beyond comprehension. The sun's path isn't perfectly smooth. As it orbits the galactic center, it also oscillates up and down through the disk, rising and falling like a boat on a slow tide. Each cycle takes tens of millions of years. When it passes through the densest part of the disk, it encounters more dust gas and gravitational influence. When it moves above or below, it enters quieter regions. Some scientists have speculated that these oscillations might subtly influence conditions on Earth, perhaps by increasing exposure to cosmic radiation or altering the number of comets that enter the inner solar system. Whether or not those effects are real, the image of our solar system bobbing gently through the galactic plane is an accurate one. We are passengers in a slow wave, lifted and lowered by the gravity of billions of stars. Beyond the boundaries of the Milky Way, the galaxy itself is moving. It's part of a small cluster of galaxies known as the Local Group, which includes Andromeda, the Magellanic Clouds, and a few dozen smaller companions. Within this group, each galaxy moves relative to the others, their mutual gravity binding them together. The Milky Way and Andromeda. The two largest members are on a slow collision course. They're currently about 2.5 million light years apart, approaching each other at around 110 kilometers per second. That might sound fast, but the scale is so large that they won't meet for another 4 billion years. When they do, their stars will mostly pass harmlessly by each other, their gravity reshaping both galaxies into a new form. The orbits of planets like ours may shift slightly, but space is so empty that direct collisions between stars are unlikely. The merger will be grand, but silent, an event of light and gravity playing out over billions of years. Even now, the Milky Way moves through a larger structure called the local sheet, which includes several nearby groups of galaxies. The entire sheet drifts toward a region known as the Virgo cluster, a massive concentration of galaxies that exerts a gravitational pull across tens of millions of light years. Our motion toward that cluster is part of an even larger flow. The galaxies of our local region are all being drawn toward an immense gravitational center called the Great Attractor, located hundreds of millions of light years away. This movement isn't chaotic. It's part of the large-scale structure of the universe. Galaxies gather in clusters. Clusters form superclusters, and those superclusters flow together along filaments of matter that stretch across the cosmos. Every level of structure participates in motion, shaped by gravity, an invisible network connecting everything. Undines, Raktins. When you think about that, it becomes clear that the concept of being stationary is only ever local. You can stand still relative to the ground, but the ground is turning with the Earth. The Earth is orbiting the Sun. The Sun is orbiting the galactic center. The galaxy is moving toward other galaxies. Even those larger flows exist within a universe that's expanding in all directions. There is no fixed point in space where you could stop and say, this is absolute rest. Everything is in motion relative to something else. Stillness is an illusion created by shared movement. This motion, though enormous in scale, is balanced by time. It's so slow that on a human level, it's invisible. The constellations we see in the night sky look the same today as they did thousands of years ago, but they're gradually changing. Over millions of years, those familiar patterns will distort as stars drift along their individual paths. Eventually, entirely new constellations will form. The night sky we know is temporary, a passing arrangement within the long flow of galactic motion. But it changes so slowly that for us, it feels eternal. We live inside a moment that lasts for ages. The idea that everything is drifting can feel unsettling at first. We like to think of home as fixed as something solid in a moving world. But in cosmic terms, everything we call stable, the continents, the oceans, even the sun is in motion. The comfort comes from realizing that motion is normal. It's the background state of the universe. Even atoms vibrate constantly. The spaces between galaxies expand. The planets circle endlessly, and gravity maintains their order. The quiet drift of cosmic motion isn't chaos, it's equilibrium in motion. It's what allows the universe to exist without collapsing or freezing. If you could see motion on these scales, sped up, it would look like a slow dance of light. Galaxies turning, merging, drifting apart. Clusters forming webs of gravity that stretch and shift like breathing fabric. The Milky Way's spiral arms would unwind and wind again, stars circling in smooth patterns while new ones ignite in the gaps. To watch it in real time would take more than a lifetime. It would take all of human history multiplied many times. The universe moves on a timeline that dwarfs every story we know, and yet that same motion happens right now, continuously all around us. The calmness of this motion hides the energy it represents. Every object with mass influences every other, no matter how far away. Gravity acts across all distances, weak but persistent. It shapes the paths of planets, stars, and galaxies, curving space itself. The quiet drift we experience is the visible expression of that curvature, a universe shaped by the pull of everything on everything else. It's easy to forget that when we look at the sky, we're seeing not just points of light, but trajectories. Every star following a curve through space-time. Those curves define the geometry of the cosmos. The expansion of the universe adds another layer to this motion. While galaxies move within their clusters, under gravity space itself expands between clusters. This isn't like objects moving through space. It's the stretching of space itself. The farther apart two galaxies are, the faster they appear to move away from each other. That expansion carries everything with it like dots on an inflating balloon. The galaxies themselves aren't flying outward through pre-existing space. They are part of the fabric that stretches. This means that even the quiet drift of our galaxy is embedded within a larger flow, a movement that has been ongoing since the beginning of time. When astronomers measure this expansion, they describe it in terms of redshift, the stretching of light as space expands. The more distant a galaxy is, the more its light shifts toward longer wavelengths. That shift tells us not only how fast it's moving away, but also how long its light has been traveling. By mapping these shifts, scientists can trace the structure of the universe and see how matter flows through it. The pattern that emerges is not random. It looks like a web. Vast filaments of galaxies and clusters connected across unimaginable distances, separated by enormous voids where very little exists. The Milky Way lies along one of those filaments, moving with its neighbours through the cosmic web. Our drift isn't isolated. It's part of the flow of everything. Even within that grand structure, small emotions persist. Stars within galaxies orbit their centres. Planets orbit stars. moons orbit planets. The hierarchy of motion extends downward indefinitely, each scale nested within another. The quietness of it doesn't mean it's simple, it means it's balanced. The universe achieves stability through motion. Every orbit, every rotation, every expansion serves to distribute energy to maintain equilibrium. If anything were truly still, gravity would pull it inward until motion began again. Stillness in physics is temporary. Motion is permanent. Our position within this network of motion is not random. The solar system moves in a particular direction through the galaxy toward a point in the constellation Hercules. The entire Milky Way moves toward the Great Attractor, a region of space so massive that its gravity influences hundreds of thousands of galaxies. And beyond even that, there's another pull toward a still larger structure called the Shapley supercluster. The farther we look, the more layers of motion we find, each one part of a larger flow. The universe has no single center, only centers within centers, each defined by the gravity of its contents. It's humbling to realize that every moment of our lives unfolds within this quiet drift. The motion is constant, but it's also predictable. The same forces that carry galaxies across space hold us to the Earth, keep the moon in orbit, and guide the planets around the sun. The same laws describe the path of a falling leaf and the orbit of a galaxy. Scale changes, but the rules do not. That consistency is what allows us to make sense of the universe at all. We can't feel the motion, but we can understand it, measure it, and even predict it millions of years into the future. Sometimes, when scientists simulate the universe's evolution on supercomputers, they see this motion play out in slow elegance. Clouds of matter collapse into galaxies. Galaxies form clusters. Clusters flow along filaments. Over billions of years, the patterns evolve, but the overall shape, the cosmic web, remains. It's a structure that looks alive, though it isn't alive in the biological sense. It's the physical outcome of gravity acting over time. What we call the quiet drift of cosmic motion is that same process continuing everywhere, shaping everything we see, even within the small scale of the solar system. The idea of rest doesn't really exist. The Earth rotates once every 24 hours, orbits the Sun once every year, and follows the Sun through the galaxy. The Moon moves around the Earth, and both move together around the Sun. Every atom in your body moves with that same rhythm, participating in each layer of motion simultaneously. When you sit still, reading or thinking, you're in fact spinning, orbiting, and drifting through space at tremendous speed. The silence of it doesn't mean it's not happening. It only means that motion at this scale feels like stillness, because everything near you shares it. It's worth noticing that this constant motion doesn't lead to instability, quite the opposite. It creates the conditions for balance. The Earth's orbit keeps its temperature within a range that allows life. The galaxy's rotation keeps its structure intact. The expansion of the universe prevents everything from collapsing back into a single point. Motion distributes energy evenly enough for complexity to arise. Without it, there would be only compression and stillness, and neither could sustain the universe as we know it. From a certain perspective, this quiet drift connects everything. The atoms that make up your body were once part of stars that orbited other parts of the galaxy. Those stars drifted and died, scattering their elements into space where they mixed with gas and dust that eventually formed the Sun and Earth. The particles that make you are still in motion, orbiting, vibrating part of the ongoing circulation of matter and energy. Cosmic motion isn't something separate from us. It's the background condition that defines our existence. It can be difficult to appreciate that while we move through space itself also moves through time. The universe is not static, but dynamic, expanding, cooling, and changing. Galaxies shift positions, clusters stretch apart, the large-scale pattern of motion continues even as local systems like ours maintain their internal balance. Everything flows, but within that flow are stable eddies, stars, planets, life. The stillness we experience on Earth is one of those eddies, a calm region within a sea of constant movement. If you could somehow watch the entire history of the universe unfold in a single glance, you'd see motion at every scale. Matter clumping together under gravity, collapsing into stars, forming galaxies, merging into clusters. You'd see waves of energy from ancient explosions spreading outward, rippling across the cosmic web. The quiet drift that we experience now would look in that view like a vast coordinated dance, billions of points moving together according to simple unbreakable rules. From within, it feels still. From outside, it's endless motion. And through all of it, there's no sound, no visible sign of speed, no sense of acceleration. Just the slow, steady flow of everything toward everything else, shaped by gravity, stretched by expansion, guided by the same principles that hold atoms together. We live within that motion, surrounded by it, dependent on it. Though we rarely think about it, it's the quiet background of existence, the constant drift of the cosmos carrying us forward through space and time. The Milky Way, vast as it is, does not drift alone through the darkness. Around it, like quiet companions on a long journey, other galaxies turn slowly through space. Some are small and faint. Others glow with their own light, their own billions of stars. Together, they form what astronomers call the local group, a neighborhood of galaxies bound by gravity, moving together through the expanding universe. It's easy to imagine the Milky Way as isolated, floating in an empty void. But when you pull back far enough, you see it surrounded. More than 50 galaxies orbit nearby, each one a separate island of stars, yet all connected by invisible threads of gravity that reach across millions of light years. They're not randomly scattered. They belong to each other, the way moons belong to planets, the way planets belong to stars. Within this quiet assembly, two galaxies stand out, the Milky Way and Andromeda. They are the largest, the brightest, the anchors of the group. Everything else orbits around them, drawn by their combined mass. And though they're separated by an immense distance, they are slowly, inevitably moving toward each other. Andromeda lies about 2.5 million light years away. That means the light you see from it tonight left its stars before the earliest humans walked the Earth. It's the most distant object you can see, with the naked eye, a faint smudge in the constellation it's named for. Through a telescope, it becomes a luminous spiral, tilted slightly, its arms winding outward in elegant curves. It looks peaceful from here, but it's heading toward us. The two galaxies are approaching each other at roughly 110 kilometers per second. That sounds fast, but the scale is so enormous that they won't meet for another 4 billion years. When they do, it won't be a collision in the way we imagine, no crashing, no shattering. The stars are so far apart that they'll mostly pass through each other like ghosts. But their gravity will twist and stretch both galaxies, pulling them into new shapes. Over hundreds of millions of years, the spirals will distort, merge, and eventually settle into a single larger galaxy, probably elliptical in form, its stars scattered in a soft cloud rather than a flat disk. By the time that happens, the sun will have already expanded into a red giant, its warmth no longer gentle. But the stars themselves, most of them will survive. They'll simply find themselves in a new formation, orbiting a new center part of something that hasn't been named yet. The merger will be slow, silent, and beautiful, a dance of light and gravity playing out over billions of years. There's no violence in it, only transformation. Two vast structures becoming one, their stars mingling like rivers flowing together into a single current. Closer to us within the gravitational pull of the Milky Way are smaller companions. The Magellanic Clouds, two irregular galaxies visible from the southern hemisphere. They look like pieces of the Milky Way that have broken off and drifted away, glowing softly against the dark. The large Magellanic Cloud and the Small Magellanic Cloud have been orbiting our galaxy for billions of years, pulled along by its gravity. They're not perfectly stable. Their shapes are distorted by the Milky Way's tidal forces, stretched and twisted as they move. Streams of gas and stars have been pulled away from them, forming faint bridges that connect them to our galaxy. Eventually, over the course of billions of years, they may be absorbed completely, their stars added to the Milky Way's count, their light becoming part of ours. For now, they remain separate small islands in the galactic sea. From Earth, they appear as hazy patches of light, like clouds that never move. Ancient travelers in the southern hemisphere used them for navigation, the way northern sailors used the North Star. They didn't know they were looking at entire galaxies, millions of stars, each one a sun, each one possibly surrounded by worlds of its own. The local group, with all its members, is held together by gravity, but it's also moving as a whole, drifting toward a larger structure, the Virgo cluster, a massive concentration of galaxies tens of millions of light years away. That pull shapes the motion of everything in our neighborhood. We are not static, not anchored. We are part of a flow that extends far beyond what we can see. When you think about these galactic neighbors, it becomes clear that the universe is not a collection of isolated objects, but a network. Every galaxy influences every other, even across unimaginable distances. The light from Andromeda reaches us. The gravity of the Magellanic Clouds tugs at the Milky Way's edges. We are connected not by touch, but by motion and time. So as you drift towards sleep tonight, picture that quiet assembly, the Milky Way, turning gently in space, surrounded by its companions. Andromeda approaching slowly across the void. The Magellanic Clouds trailing behind like faithful shadows. All of them bound together, moving through the darkness, part of the same ancient rhythm that began long before stars had names. There is a boundary to what we can see. Not a wall, not an edge you could point to, but a horizon drawn by time itself. Beyond it, light has not yet had enough time to reach us. The universe may continue forever in all directions, but we are surrounded by a sphere of visibility, a bubble defined not by distance alone, but by the age of everything that exists. That bubble is about 93 billion light years across. It sounds vast, and it is, but it's not infinite. Somewhere beyond that limit, stars are shining, galaxies are turning, and events are unfolding that we will never see. The light from those places is still traveling toward us, but it hasn't arrived yet. And because the universe is expanding, some of it may never arrive at all. This is what astronomers call the observable universe. It's the portion of space from which light has had time to travel since the beginning. Everything beyond it remains hidden, not because it's dark, but because its light is still on the way. It's like standing in a vast room where the walls are so far away that sound takes years to reach you. You know the room continues, but you can't hear what's happening at its edges. The boundary isn't fixed either. Every second light from farther away crosses into our view. The observable universe grows slowly as photons that have been traveling for billions of years finally arrive. But at the same time, the expansion of space carries distant galaxies away faster than their light can reach us. So there are regions we see now that we will eventually lose, drifting beyond the horizon, fading from view forever. When you look deep into space, you're also looking back in time. Light takes time to travel, so the farther away something is, the older the image you see. The sun's light is 8 minutes old. Sirius is 8 years old. Andromeda, 2.5 million years. The farthest galaxies we've detected are more than 13 billion light years away. Their light has been traveling since the universe was young, less than 1 billion years after the Big Bang. To see them is to witness the past. They appear not as they are now, but as they were when the light left them. By now, those galaxies have changed, evolved, perhaps merged with others, but we'll never know their present state. We can only see their history preserved in the light that finally reaches us. The most distant thing we can observe isn't a galaxy at all. It's a faint glow that fills the entire sky, so uniform, so smooth, that it took decades to detect. It's called the cosmic microwave background, and it's the afterglow of the Big Bang itself. About 380,000 years after the universe began space, cooled enough for light to travel freely for the first time. That light has been journeying ever since, stretched by the expansion of space into microwaves. When we measure it, we're seeing the universe as it was in its infancy, before stars, before galaxies, before anything we recognize. It's the oldest light in existence, and it surrounds us completely. In every direction, if you could see in microwave wavelengths, you would see that faint, ancient glow, a memory of the moment when the cosmos became transparent. Beyond that glow, there is more universe. There must be, but we cannot see it. Light from those regions hasn't had time to reach us yet. The farther back we look, the closer we get to the beginning, and the beginning itself is veiled, not because it's hidden, but because light didn't exist in the way we know it until space cooled enough to let it move. This means there is an event horizon to our knowledge, a limit not imposed by our instruments, but by physics itself. No matter how powerful our telescopes become, we will never see beyond the observable universe as it stands at this moment. The expansion of space ensures that some regions will remain forever out of reach, their light perpetually travelling toward us, but never arriving. It's strange to think about. Somewhere right now, galaxies are forming, stars are exploding, worlds are turning, and we will never know. They exist beyond the edge of what can be observed, beyond the reach of light and time. They are as real as anything we see, but they are invisible, unreachable, separated from us by the simple fact that the universe hasn't existed long enough for their light to arrive. And yet the boundary is not empty. It's filled with meaning. The observable universe is not just what we can see, it's what we can know. It's the sum of every signal, every photon, every trace of information that has had time to reach us. It defines the limits of our awareness, and within those limits, we find everything we've ever studied, wondered about, or named. In a way, the horizon is comforting. It reminds us that the universe is larger than we can ever comprehend, that no matter how much we learn, there will always be more beyond. The edge of visibility is not an end, it's an invitation to imagine what lies farther. As the universe continues to expand, that horizon will shift. Some of the galaxies we see now will drift beyond it, their light redshifted into invisibility. Others currently beyond reach will cross into view for the first time. The cosmos is always revealing itself and always hiding a slow exchange between the known and the unknown. So when you look up at the night sky, remember that you're seeing only a small part of what exists. Beyond the stars, beyond the galaxies, beyond the farthest light, there is more. And though we'll never see it all, the fact that it's there, vast silent continuum, is enough. The universe doesn't need to be fully known to be felt. It only needs to be acknowledged quietly in the dark as you drift towards sleep. When you realize how small you are within the Milky Way, it's tempting to feel diminished, as if size were the only measure of importance, as if being small meant being less. But the universe doesn't work that way. Smallness is not the absence of meaning. It's the structure that allows meaning to exist at all. Everything in the cosmos is nested within something larger. Atoms form molecules. Molecules form cells. Cells form bodies. Bodies stand on planets. Planets orbit stars. Stars gather into galaxies. And galaxies cluster into filaments that stretch across the universe. At every level, the small makes the large possible. Without the tiny, there would be no vast. You are small compared to the Earth. The Earth is small compared to the Sun. The Sun is small compared to the galaxy. And the galaxy, immense as it is small within the observable universe. But none of that makes any level less real, less necessary, or less significant. Each scale has its own role, its own processes, its own kind of order. The universe is not a hierarchy of value, it's a continuity of structure. What's remarkable is not that you're small, but that you're aware of it. Somewhere within the vastness of the Milky Way, on a planet orbiting an ordinary star, a pattern of matter has become conscious. Your brain, 3 pounds of tissue, small enough to hold in 2 hands, can comprehend distances that span billions of light years. It can picture the spiral of the galaxy, trace the motion of stars, and wonder about its own place within it all. That awareness is rare. As far as we know, most of the universe is not conscious. Stars burn without knowing they burn. Galaxies turn without feeling their motion. The cosmos unfolds in silence, governed by physical laws that require no witness. And yet here you are, a small arrangement of atoms that can think, feel, and ask questions. That makes you rare in a way that size cannot measure. The smallness of your body allows for complexity. If you were as large as a planet, your thoughts would take hours to form signals traveling too slowly across vast distances. If you were as small as an atom, there wouldn't be enough structure to hold memory or intention. You exist at a scale where matter can organize itself into patterns intricate enough to sustain awareness. Your size is not a limitation, it's the condition that makes you possible. And everything that makes you is connected to the cosmos in the most literal way. The calcium in your bones was forged in the heart of a dying star. The iron in your blood came from a supernova explosion. The oxygen you breathe, the carbon in every cell, all of it was made in stellar furnaces billions of years ago, scattered into space, and eventually gathered into the cloud that formed the sun and planets. You are not separate from the universe. You are made of it. Every atom in your body has a history that stretches back to the beginning. You're not standing apart from the galaxy, observing it from the outside. You're part of its substance, a temporary pattern within the same matter that fills the stars. When you look up at the Milky Way, you're seeing your origin, the place where the elements of your existence were born. The same laws that govern the motion of galaxies also govern the behavior of atoms. Gravity shapes both the fall of an apple and the orbit of a star. Light behaves the same way whether it crosses a room or crosses a galaxy. The forces that hold your body together are the same ones that hold planets in orbit and stars in clusters. There is no boundary where the rules change. The universe is continuous, and you are part of that continuity. In a way, being small gives you access to detail that larger scales cannot have. A galaxy cannot know the texture of rain, the warmth of sunlight on skin, the taste of water. It cannot wonder, cannot feel relief or curiosity or peace. Those experiences require smallness, a body compact enough to sense its surroundings, a mind quick enough to process thought in real time. The vastness of the galaxy is powerful, but it's also distant, diffuse, impersonal. Your smallness allows you to be here now, feeling this moment as it unfolds. There is a quiet strength in that. You exist at a scale where individuality is possible, where a single thought can matter, where a single choice can ripple outward in ways that the slow turning of galaxies cannot. The universe is vast and patient, but it is also made of moments, brief, precise, singular. And you are one of those moments, a small flicker of awareness in the great turning, but aware nonetheless. When you think about the nested structure of existence, it becomes clear that there is no level that can be removed without everything else collapsing. Take away atoms, and there are no stars. Take away stars, and there are no heavy elements. Take away planets, and there is no place for complexity to grow. Take away awareness, and the universe continues, but it does so without ever knowing itself. Every level depends on the others. The small and the large are partners, not opposites. Your smallness within the Milky Way is not an accident or a failure of cosmic design. It's the natural result of a universe that builds complexity through layers. You are small because the galaxy is large, and the galaxy is large because it is made of countless small things. Stars, planets, atoms, particles, all working together across unimaginable distances. The size of the whole depends on the size of the parts. You are one of those parts, and without you, the whole would be different. It's worth noticing that the farther we look into space, the more we find the same elements, the same patterns, the same laws. Carbon behaves the same way in distant galaxies as it does here. Light travels at the same speed everywhere. Gravity pulls with the same patience across every distance. The universe is not chaotic or arbitrary, it's consistent. And that consistency means you are not an outsider looking in. You belong to the same structure, follow the same rules, and participate in the same processes that shape everything else. Consciousness itself is a mystery we haven't fully solved. We don't know why matter arranged in certain ways becomes aware, but we know it happens. And it happens here in you in this moment. That awareness is fragile, brief, and small compared to the age and scale of the cosmos. But it is also profound. It turns the universe from something that simply exists into something that can be known, felt, and wondered about. So when you feel small tonight, let it be a reminder, not of insignificance, but of connection. You are small within the galaxy, yes, but you are also made of the galaxy. You carry its history in every atom. You follow its laws in every breath. And in your smallness, you hold something the vastness cannot awareness of itself. A single point in space where the universe has learned to look back at its own immensity and ask quietly what it all means. That question, small as it is part of the cosmos too. It arises naturally like stars, forming from clouds of gas. And though you may never find a final answer, the act of asking is enough. It connects you to everything, the stars, the dark, the motion, the light. You are small, but you are here. And that is not nothing. It is everything. If you could trace the history of every atom in your body, you would find that none of them began here. They came from somewhere else, somewhere far away, somewhere ancient. The carbon in your cells, the oxygen you breathe, the iron in your blood, all of it was made inside stars that lived and died long before the sun existed. Those stars burned for millions or billions of years, fusing lighter elements into heavier ones deep within their cores. When they reached the end of their lives, some of them exploded, scattering their contents across space. The shock waves from those explosions rippled through clouds of gas and dust, compressing them, triggering the birth of new stars. And among those new stars was ours, the material that formed the sun, and the planets, the same material that eventually became you, was inherited from earlier generations of stars. You are made of recycled starlight. The atoms that form your bones once floated freely in the Milky Way, drifting through the dark for billions of years before gravity gathered them into this small corner of space. When you hold your hand up and look at it, you're seeing matter that has traveled across the galaxy. The calcium that gives structure to your skeleton was forged in a supernova. The iron that carries oxygen through your blood came from the collapse of a massive star. Even the hydrogen and water, the simplest, oldest element, was born in the first moments after the Big Bang, when the universe was still too hot for anything else to exist. You are not just on the Earth. You are not just in the Milky Way. You are made of the Milky Way. Every part of you is woven from the same substance that fills the stars, planets, and clouds of dust. There is no separation between you and the cosmos. You are a continuation of it, a small expression of the same matter and energy that has been cycling through the galaxy for billions of years. And the recycling never stops. When you breathe, you take in oxygen that was once part of ancient oceans, prehistoric forests, and distant stars. When you exhale, you release carbon dioxide that plants will absorb, turning it into new leaves and roots. The atoms in your body are constantly being replaced, new ones arriving, old ones leaving. Over the course of a few years, almost every atom in your body will have been exchanged for another. You are not a fixed object, but a pattern, a temporary arrangement of matter that flows through you, like water through a river. The river remains, even though the water is always changing. In the same way, you remain, even though the atoms that make you are always moving, always cycling, always returning to the larger flow of the galaxy. Right now, as you rest, you are moving. Not just the small movements of breathing or shifting position, but the enormous silent motion of the Earth itself. The planet spins beneath you at over 1,000 kilometers per hour. It orbits the sun at 30 kilometers per second. And the sun carrying the Earth and everything on it travels through the galaxy at more than 200 kilometers per second. You are always in motion, even when you feel perfectly still. You're gliding through space along with the sun, the planets, and the billions of other stars in the Milky Way. You don't feel it because everything around you is moving at the same speed: the air, the ground, the trees, the mountains. But the motion is real, constant and shared. In a way, you belong to that motion. You're not sitting on a stationary planet watching the universe go by. You're part of the flow itself, carried along by the same gravitational currents that guide stars and galaxies. Every moment of your life unfolds within that drift, whether you notice it or not. You are a passenger on a journey that began long before you were born and will continue long after you're gone. And yet, despite being so small, so brief, so temporary, you hold something extraordinary. Somewhere within the structure of your brain, within the firing of neurons, the flow of signals, the delicate balance of chemistry awareness arises. You can think, you can feel, you can look up at the night sky and recognize what you're seeing. The universe, through you, has become aware of itself. For billions of years, stars burned without knowing they were burning. Galaxies turned without feeling their motion. Space expanded in silence with no one to witness it. And then, on at least one small planet, matter organized itself into patterns complex enough to ask questions, to wonder, to know. You are one of those patterns, a fleeting moment of self-awareness within a cosmos that is mostly unconscious. The atoms in your brain follow the same physical laws as the atoms in distant stars, but they have arranged themselves in a way that allows thought to emerge. You are the universe, looking back at itself, briefly, quietly, before the pattern dissolves and the atoms return to the flow. There's something deeply strange and beautiful about that. The Milky Way, vast and ancient as it is, does not know it exists, but you do. And in knowing, you give it a kind of presence it wouldn't otherwise have. Your awareness is small, yes, a tiny spark in the dark, but it is also precious because it is rare. As far as we know, consciousness is not common. It may be scattered across the galaxy in forms we haven't found yet, or it may be unique to this one small world. Either way, it matters. Scientists sometimes point out that the structure of the brain, the way neurons connect and communicate, resembles the large-scale structure of the universe. Galaxies cluster along filaments, forming a web that stretches across billions of light years. Neurons connect in networks, forming webs of thought and memory. The patterns are similar, even though the scales are vastly different. It's as if the universe, in creating consciousness, has repeated its own structure at a smaller level. The same principles of connection, flow and complexity appear again and again at every scale, from atoms to galaxies. You are not separate from that pattern. You are an example of it, a small reflection of the larger whole. When you close your eyes tonight and let your thoughts slow down, remember that the darkness behind your eyelids is the same darkness that fills the space between stars. The quiet you feel is the same quiet that surrounds distant galaxies, and the sense of being here now, aware that's the universe, recognizing itself briefly in the form of you. You carry the Milky Way within you, not as a metaphor, but as a physical truth. The elements in your body were made in its stars. The motion of your life follows its motion through space, and the awareness you hold, fragile and temporary as it is part of the same unfolding process that has been shaping the cosmos since the beginning. You are not standing outside the galaxy looking in. You are woven into it completely, part of its matter, part of its motion, part of its long, slow story. When you look up at the stars, you're not seeing something distant and foreign. You're seeing home, the place where you came from, the place you've always belonged. And though you're small within it, so small that no telescope could ever find you, you are not insignificant. You are a part of the whole, made of the same substance, following the same laws, participating in the same vast dance of matter and energy. The galaxy is in you as much as you are in it, And that connection, quiet and invisible as it is something worth resting in as you drift towards sleep. And now, here we are, back where we started, in this quiet room, in this gentle moment, on a small planet turning softly through the dark. We've travelled far tonight, from the ground beneath you to the edge of the observable universe, from the familiar warmth of the sun to the cold distances between galaxies, from the scale of atoms to the scale of cosmic horizons. But through it all, you haven't moved. You've been here the whole time, breathing slowly, letting your thoughts drift along with the words. The journey was in your mind, but the connection is real. Everything we explored tonight exists around you, above you, within you, all at once, all the time, whether you think about it or not. We began with a simple question: how small are we inside the Milky Way? And the answer, as it turns out, is both humbling and comforting. Yes, you are small. Smaller than a planet. Smaller than a star. Smaller than the distances between stars. So small that the galaxy itself would never notice if you weren't here. But smallness is not the end of the story. It's only the beginning. Because within that smallness, you hold something: vast awareness, thought, the ability to wonder. You can look up at the night sky and understand what you're seeing. You can trace the motion of stars, imagine the spiral of the galaxy, and feel the quiet pull of distant worlds you'll never visit. That capacity is rare, precious, and profound. We travelled outward from Earth, measuring distance in steps that quickly outgrew intuition. The moon just over a second of light away. The sun 8 minutes. The edge of the solar system hours. The nearest stars years. The far side of the galaxy 100,000 years. And beyond that, millions and billions of light years stretching toward a horizon we can never cross. At each step, the numbers grew larger, the emptiness deeper, the silence more complete. But at every scale, we found the same truth: everything is connected. The motion of planets is shaped by the sun. The sun is shaped by the galaxy. The galaxy is shaped by its neighbours and by the unseen dark matter that holds it together. Nothing exists in isolation. Everything flows into everything else, part of the same continuous structure. You are part of that structure, not as an observer standing outside it, but as a participant woven into it. The atoms in your body came from stars. The motion of your life follows the motion of the sun through space. The air you breathe was shaped by billions of years of planetary evolution, itself guided by the light and gravity of a single ordinary star in a quiet arm of the Milky Way. When you inhale, you're drawing in matter that has cycled through oceans, forests, and ancient atmospheres. When you exhale, you're returning it to the flow, where it will become part of something else: a leaf, a cloud, a wave. You are not separate from the world around you. You are a pattern, within it temporary, but real small, but necessary. And the same is true on the largest scale. You are not separate from the galaxy. You are made of it, shaped by it, carried along by its motion. The spiral arms, the distant stars, the glowing band of light that arches across the night sky, all of it is home. Not in a poetic sense, but in a literal one. You belong to the Milky Way as much as any star, any planet, any cloud of dust drifting through the dark. Tonight, as you rest, the galaxy continues its slow turn. Stars are born in distant nebulae. Old stars collapse and scatter their elements into space. Planets orbit quietly, moons rise and set, light travels across unimaginable distances. And somewhere within all of that, on one small world, in one quiet moment, you are here, aware of it, part of it, connected to it in ways you can feel, even if you can't always name them. The night sky is not something distant or separate. It's the ceiling of your home. Every point of light you see is a neighbour, however far away. Every glimmer is part of the same structure that holds you. And when you look up, you're not looking out, you're looking through the atmosphere, through the solar system, through the spiral arms, into the deep fabric of the galaxy itself. That connection doesn't require anything from you. You don't have to understand every detail or remember every number. You don't have to feel small or large, significant or insignificant. You only have to notice quietly that you are here, and that here is not a lonely place. It's part of something vast, ancient, and ongoing, a process that has been unfolding for billions of years and will continue long after this moment fades. So let yourself rest now. Let the weight of distance and time settle gently around you, not as a burden, but as a reminder. You are held by gravity. You are warmed by starlight. You are made of matter that has journeyed across the galaxy to become you briefly before moving on to become something else. Every breath you take is a small part of that journey. Every thought, every heartbeat, every moment of awareness. It all happens within the quiet turning of the Milky Way. You are not outside the cosmos, looking in. You are inside it, woven into it, belonging to it completely. Thank you for drifting with me tonight, for letting your mind wander through distances too large to hold, and for returning here to this small, familiar place with a deeper sense of where you are. The stars are still shining above you, even if you can't see them. The galaxy is still turning, carrying you with it. And you are still here, resting softly part of it all. Sleep well, and when you wake, remember the night sky is not somewhere else. It's here. You are surrounded by it, made of it, moving through it. You are small, yes, but you are also connected to everything, and that connection, quiet and invisible as it is, will always be there, waiting for you to notice it again. Good night. Retry. Claude can make mistakes. Please double check responses. Sonnet 4.5.